Hello, and welcome to the Bitcoin.review podcast, where we explore developments and projects with the people who actually make them happen. The show is supported by Pod 2.0, Sat Streaming, and CoinKite. If you're a new listener, I'm NVK. I run CoinKite, where we've been helping people secure their Bitcoins for over a decade. We make the cold card and fun products like the block clock. You can find more information about it on coinkite.com. Hello, and welcome back to the Bitcoin.review Sleeping Aid Society. Just kidding. We're going to put you to sleep as best as we can. This is not an episode about people. It's about ideas. So I cannot offer you drama. Sorry. If you want that, there is other podcasts for that. Anyways, so I have an absolute rock star team here. I have Mr. Rijndael, who comes and goes.
Thanks. Great to be back.
I have Mr. Andrew Poelstra.
Yep. Thanks.
And Rob Hamilton.
Thanks for having me.
So I think it's overdue now for a OpCat episode where we take the time and we explore a little bit, both from 20,000 foot view all the way down to some specifics. And, why am I doing this, I guess? It's very similar to the episode we did with the SegWit part, is that, this is very complicated shit. Very, very complicated stuff, right? And, it really distills down to a single opcode and like a very tiny little thing that it does, right? But it causes a lot of complication in Bitcoin. Bitcoin is a very complicated dynamic system. And there's a lot of fear on things. There's different actors with different interests that want things and don't want things. So I kind of want to explore a lot of different ones around this topic. And I don't think the three of you need any introductions aside from your names for the audience that listen to this podcast. I think anyone that's listening to this already know who you are.
All five of them.
Yeah, all five of them, right?
Wow, that's a doubling of viewership. That's great.
I know. It is kind of funny, though. It's a little weird. I was in a conference and more than one or two people came say that they listened to the podcast. That was a little unsettling. Looking like an idiot for this amount of people is not fun. Anyways. All right. So why don't we have just like a very brief, like a 1 minute sort of like history of OpCat, right? Like, just like, because people need to know that OpCat was in Bitcoin. OpEval was added to Bitcoin too. So there were many ops that were removed from Bitcoin. And, just because it's a BIP or just because it's a thing that was and isn't anymore, it doesn't mean that it has to be there again, right? Or could come back again. A lot of people don't understand this nuance about Bitcoin that has changed through time. So who wants to just give like a very, very, very brief just run through of like OpCat history?
Sure. All right, I'll take it. So Bitcoin was launched in 2009, right? I guess it was written in 2008 and then launched. The original Bitcoin source code had a script interpreter, which survives to this day, that allows you to do all sorts of complicated calculations and stuff like that. And it included a lot of kind of interesting comments in the source code that suggested that Bitcoin was supposed to be a form of programmable money. And there was also some really like kind of crazy stuff. Like, I think there was like an eBay like trading thing that was kind of commented in there. And I guess Satoshi intended one day to try to build that before.
Poker too.
Poker game.
Yeah, right. Like all this crazy stuff that wasn't there. But what was there in actual code, not just comments, was a script interpreter that allowed you to run arbitrary programs on your coins, and then you could spend the coins if they satisfied that program. And the programming language was this thing called script. It had a bunch of opcodes, including all the ones we know and love today, as well as one called cat. And what happened was in 2010, kind of mid-2010, there was something of maybe a revolution in the way that we understood Bitcoin, the way that we understood consensus algorithms. So if you go like digging through old Bitcoin talk posts, you'll find that like the phrase soft fork appears at this time. And like there was no such thing as a soft fork before. Before they were like, opcodes like opver that today we would understand to be like an opcode that always hard forks everything. So Satoshi removed a whole swath of stuff, both in response to kind of understanding the nature of forks. So he removed opver, and he also added all of the no-op opcodes, which were later used to soft fork and things. And also, there were CVEs against Bitcoin. It was determined that a number of the opcodes had bad behavior that could crash nodes or cause them to fall out of consensus or something like that. And specifically with opcat, the problem was that you could use it to create arbitrarily large data on the stack. You could take, like a single byte or something, and you use opt-up. Now you have 2 bytes, and cat, you put them together, and then you dup that. Now you have 4, cat, put them together, right? You dup it, you have 8 and 16, 32, and these numbers very quickly become very large. And with just, a couple hundred bytes of writing that, you can quickly get something that requires more memory than could ever fit into the universe. So Satoshi kind of panicked and just disabled everything, right? There's kind of a solution to this, right? You just limit the size of the things that you can do with opcat. But it wasn't just cat, right? Opmul and the arithmetic opcodes had similar explosions. They were bit shifting opcodes that did like weird things if you stepped outside of the bounds of the underlying C++ language. There are a couple other things that I'm forgetting now, and Satoshi like, whoa, and just disabled all of them.
And people need to understand, right? There were a lot less people reviewing the code. There was nobody really running the code. It was just like a handful of people at this time. Like, it's like, look at all this design space I built, right? Oh, hang on a second. All this design space is not ready for production. Let me reduce this, make this thing functional, right? And so that we can keep on moving and we can maybe add stuff later.
Yeah, it's true. It's not obvious that anybody reviewed this, actually, because you can go look at the source code history in Git, and you'll see that this, of course, dates to the pre-Git days when it was all SVN, but each SVN commit has now been transferred to Git. And you'll see that these changes happened in commits that had like names like improved build system, or like really like generic inaccurate names. And then you read what the actual code changes are, and there's like a dozen wildly different things happening in a single change commit that if anybody was reviewing, right, that wouldn't have been accepted, right? Like it really feels like Satoshi was just writing code and pushing it at this time.
I mean, it's the classic thing when you're alone on a code base, you have a lot of like update.
Yeah.
That's all your Git commit like names.
I pulled up the diff, right? And like the commit message on this is literally misc changes. It's like this grab bag of stuff that also includes setting, a dozen opcodes to just return false, right? Like it's wild.
So thank you for that, Andrew. I guess like this sets the tone for like, you have this thing, it's very cool, it's very new. For the people who are, in the space a long time ago, you know this. It was all sort of, we were calling it an experiment up until even a few years ago, right? Some of us still do. And the problem is, right, like it's like a lot of most of the user base really of Bitcoin came way after this stuff, right? Even after the block wars, right? So like people are not familiar with this sort of like, things are changing. There's things we're trying to fix and sort of the gardening of the code and all these things. And now people have their life savings on it, and that creates a lot of fear. It creates this huge dynamics, and it's complicated, right? Everybody wants something different. But anyway, so we have opcat, right? And this thing got deactivated because we could have issues, right? So we could have essentially an explosion of data there. And it does interact with Bitcoin in a way that is sort of like affects everything in Bitcoin, right? Like it's like every script could be affected by cat, right? Or cat could affect every script, really. And so who wants to give a very good like sort of explanation of cat? What does cat do?
So, as Andrew mentioned, Bitcoin's got this script interpreter, and the programming model for Bitcoin is it's what's called a stack machine. So you have some data and you have opcodes in Bitcoin that either manipulate the stack or operate on data that's on that stack. So, you push the numbers 1 and 2 onto the stack, you do op add, and it adds the top 2 elements on the stack and like pushes the result. So now you have 3 on top of the stack. One that a lot of listeners are probably familiar with is op checksig, right? So you have a public key and signature for the transaction on the stack. You say op check sig, and it evaluates or it validates that signature is valid for the transaction that like we're running inside of. What opcat does, cat is short for concatenate, is it takes the top two elements and smushes them together and puts them on the stack. What it actually does is it takes the top two elements and kind of puts the top one at the end of the second to the top one and then removes the top one. But you can think of it logically as it just takes the top two elements, smushes them together, and then puts it right back on. So it's concatenating two elements. And so, to Andrew's explanation a minute ago about the potential denial of service vulnerability that Satoshi was worried about, if you can create, if you can like take some element, duplicate it, smush it together, duplicate it, smush it together, and just do that over and over and over again, eventually you have this element that's larger than the amount of memory that you're running on your node crashes, and one person can make a transaction that affects everybody's nodes. And I think, in general, it's generally okay if you do things that like mess up your coins. We generally don't want to let people do things that will like mess with other people's coins or mess with other people's nodes. And so that's what cat does. It takes two things, it smushes them together. The current proposal of cat obeys kind of a stack element size limit. So the idea is that you can smush things together on top of the stack, but if they get too big, then the script fails. And that's how it mitigates the issue that Andrew talked about.
25 bytes?
It's 520 bytes.
520 bytes.
Yeah. So that's what cat does at its basic. It's like 8 lines of code. It's really easy. You can read it, and like somebody made a song where they sang all the lines of the patch. It's very short, so it's easy to review. But it's useful, and we can talk about in a few minutes like why it's useful, because a lot of things in Bitcoin involve smushing elements together and then hashing them. And so being able to kind of reconstruct that behavior on the stack lets you encumber Bitcoin in new and interesting ways.
So you could almost say that like, the only real direct immediate risk is the byte like problem, right? Like it's the size problem, right? That can be fixed.
Yeah.
That's the immediate like direct risk.
Yes.
We're going to talk about other things, but like
sure.
in terms of just direct cold concern, right? It's like, okay, listen, this thing can turn into, a massive like memory problem, right? And that's an easy fix. And, we all know from OpEvol that that's a problem.
Yeah. Or I'll give you kind of a parallel example, right? Like we don't have loops in Bitcoin script. Like you can't write like a for loop or a while loop in Bitcoin script. Imagine we did. Like imagine we had a mechanism to do looping inside of your script. If somebody wrote a loop that like never terminated and then everybody's nodes are just like executing this code over and over again forever, like that would be a problem. That would stall out the network. So that kind of thing is the reason why cat was deactivated, over a decade ago, and all of the current proposals that would involve activating opcat either on its own or as part of something like Russell's Great Script Restoration, all of those things have mitigations for creating stack elements that are too large.
Okay, so now let's break down what do you mean by elements? Like what are the things that we can concatenate there and what they can do?
I think just to throw out the first thing, maybe to take the most narrow, straightforward approach, would be transaction data to actually reconstruct sig hashes on the stack. And this is Rijndael's done the work with the perfect vault to be able to, which is leveraging Andrew's blog post about like Schnorr tricks, right? You're able to basically restrict your coins in different ways by being able to reconstruct the transaction on the stack.
Yeah, that's something that we can definitely, that's super useful, and a reason why I think a lot of people like cat. Even more simple than that is just like validating a Merkle tree. Like that might be a good place to start, because I think a lot of the 4 people who are still listening at this point like probably know what a Merkle tree is, right? But like you take a bunch of elements, you hash them, and then you kind of pair off the leafs and you hash those together, and then you take all the pairs of hashes and you hash those together, and eventually you have one element that commits to a bag of items. And the idea is that you can take an element and prove membership in that bag by providing sort of like a path through that Merkle tree. We use this in Taproot, for example. This is how you can have like lots of different scripts and you choose the one that you want to spend at spend time. Merkle trees are used to commit to all of the transactions in a block. Like in the block header, there's a little Merkle root that commits to all the transactions that were included. So we see Merkle trees all over the place. And if you wanted to check in your script that some data belonged to a Merkle tree, you could do that. Like if you think about what are the steps that you would need in order to do that, what you want to be able to do is say, I've got this Merkle commitment that I've like burned into my script that I've committed to ahead of time. And then at spending time, I'm going to have somebody hand me an element and then a list of hashes that if I smush them together and hash them over and over again, will prove that that element was like previously committed to. You're now basically like walking through the Merkle path and validating that all the hashes match. That's something that you could do if you have cat and SHA. And like that's a useful construct for things like multi-party payment systems and all kinds of interesting applications. So, we should definitely talk about the covenant thing with reconstructing signature hashes. But, a common theme here is that in Bitcoin, we very frequently have hashed data that is constructed by taking a bunch of other data or a bunch of other hashes and squishing them together and hashing it. And what opcat lets us do is like reverse that process in your script and validate it, which means that you can like encumber scripts on these commitments.
Now, Andrew, do we have anything in Bitcoin right now that often offers some kind of introspection, right? Because right now, all we have is on the input side, right? Like, these are my conditions. There is no conditions on the output side, right? Because that's what these things start to do, is give you control over the output. Right now, the only output that we have condition is really like, is this a valid address
Yeah.
that I'm sending to, right?
Yeah, it's a good question, right? So we have basically the way script is designed, right? You run the program. If it accepts, you can move the coins, and it can't constrain what happens after that. Like if you sign, you can sign anything, right? You can't constrain where the coins can go. Mm-hmm. And the reason is that in script, you're embedding your script inside of a transaction, but the script can't access the transaction to say, wait, I don't like this output. There's too many coins going to one place, or it's not going to one of these whitelisted addresses. And the first order way to think about why can't you do this in Bitcoin is that there is no transaction introspection. So you might think in order to get covenants, you need transaction introspection. You need the ability to look at the transaction. And so you would need to add an opcode that can do that. And cat is not such an opcode. So some listeners may be kind of like thrown here and thinking like, what is this? Either thinking that we're all on drugs here, thinking that you can just like concatenate two elements. And
we're definitely on drugs and also shirtless.
Yes. Either you can concatenate two elements, right? And then somehow that lets you inspect transactions, right? That's ridiculous. Or maybe cat is more dangerous than we're letting on, right? I think I really think some people like kind of have that feeling, right? They look at this thing, they don't know the technicals, that really you're just squishing two things together that you already have beside each other. So why does it matter? The fact that you can do all this cool stuff is suspicious. So how does it work? The trick is that there is actually a couple of opcodes already that do transaction introspection. There are a couple boring ones, the check time locks. Okay, we've had check lock, like relative time locks and stuff. You can, if you want to be like pedantic and an asshole, you can call that covenants, but it's not really, right? Because
it is.
All you can do with it is wait for the transaction to be old enough, and then it's good. There's another opcode, a much more interesting opcode, which Rijndael alluded to, called checksig. And what that does, well, it checks that there's a signature on the transaction. But technically what's going on is looking at the entire transaction, is pulling all of the parts of the transaction out, is hashing them together, is getting what's called a hash or a digest. And then it's validating a signature that the user provides as input to the script on that digested transaction. Okay? And what that means is that it's taking all of this transaction data and feeding it into the script interpreter. And then it's doing something very specific, and then it's outputting just like a 1 or a 0, depending on whether the transaction. But the transaction data is already in the script interpreter, and it's already interacting with user-controlled input, right? The public key and the signature. So really, what we need to get covenants is not adding new introspection, although that's what we would do if we were being sane. All we need is the ability to like somehow reach into that signature algorithm and like rip this transaction data out through his throat and then get it onto the stack. Okay. And then we have it. And then we can start manipulating it. We can break it apart and validate individual parts and so on. And so checksig really is the covenant opcode that we have, or the transaction introspection opcode that we have. And right now it's very limited to prevent you from doing covenants. But it turns out, and probably we'll get to that in a question or two, but it turns out that just using opcat, you are able to reach into the signature algorithm and pull the transaction data out. And so you get this introspection, not by adding new capabilities, like non-trivial capabilities to scripts where you're like looking at the transaction where previously you couldn't. But all we're doing is adding some very small computational abilities that let you get out the transaction data that's already there.
So it's a good little spot to stick a person's question that came when I posed to the crowd, like what would have, like, you know, like questions and comments for us to bring up here, because I think like the goal of this is to sort of like educate people so that people can like have a reasonable view on this, against or for or whatever. And like, you know, why can't we do a lot of these things with Taproot and Tapleaf? I know, I feel like, see, in people's minds is that we just added this very sort of like super massive design space that allowed for dick butts to be on chain, right? So now we have this reasonable fear, really, right, for the people that are coming from that side of the conversation, that like, you know, now you can do all this stuff that's unknowns, right? And we can break Bitcoin, and we can change Bitcoin's economic dynamics. We can discuss that later. And, you know, maybe we can do some things with it that don't necessarily maybe give you all the functionality that it can do, but we can do it Taproot. Because Taproot is this big black box that got, you know, added to Bitcoin. Nobody understands.
Yeah. So as part of the design of Taproot, that's a really interesting way of framing it, that we added the ability in Taproot to put dick butts on the chain where previously you couldn't, right? Because a design goal of Taproot was actually that we weren't going to add any new functionality. We didn't extend script. We didn't add any new opcodes. Sort of. We did tweak check multisig because that had some efficiency issues. But we really didn't add any new functionality to script. What we did do, and I guess that turned out to be consequential for the dick butt connoisseurs in the ecosystem. What we did do was we simplified the way that we limit how large a single script can be, right? So previously, before Taproot, there were 2 or 3 major limits, independent limits on the size of the scripts that you could work with. And there were probably like a dozen minor limits. And when you were trying to write non-trivial programs, even just in the confines of existing Bitcoin script, right? You can already check multi-signatures and you can look for time locks and stuff, but try to do that in a non-trivial way, like what Rob's been doing with his company. And you'll quickly run into just pointless limits, right? You'll find that like if you have too many keys in a row, then maybe you run out of sigops, or if you try to do too many computations, you run into the total opcode limit, which applies, by the way, to computational opcodes, but not push opcodes, where push opcodes include a couple other random opcodes that kind of swept up in an if statement in the source code. These are not principal limits. There's just a lot of them. And so you have what's called a multi-dimensional optimization problem, trying to build non-trivial programs and staying within every one of these limits from every direction that you turn. So Taproot just cleared them all out. They said, like, so there are a couple limits, but they're very large, right? Your script can be at most 10,000 bytes or something like that. So in Taproot, we said basically all these different ways that your script might take a lot of resources, you can do them, you just have to pay for them. And so rather than having like an opcode limit, there's no opcode limit, you just pay for the opcodes that you use. Rather than having a sigop limit, you don't have a limit of the number of check sigs or whatever you can do, you just pay 50 bytes. So every sigop just is just like 50 ops. And so you have a single quantity that you're counting up. And so as a result of that, you can now do cool miniscript-like things where you can have arbitrarily complicated trees of spending conditions and arbitrarily large programs. And also, if you want to put dickbutts on the chain, you can now do so 10,000 bytes at a time, where previously you could only do so 500 bytes at a time. Okay? And really, that's not a significant change. Like really what changed is that somebody decided to put dick butts. And I'm not going to like name names certainly, but
Yeah.
what really changed is somebody decided.
No, it was a clever hack. I mean, it really was a clever hack, and it was the Bitcoin way of doing things too. Like it's we had a whole episode about that, and I think people now sort of kind of get it. At least the people who could get it.
It was a clever hack, but you could do it before. You just would have to split it up, and then the parser would have to like do a little bit of.
I mean, P2SH doesn't have a limit, right? Like a reasonable limit, so you could stick it into PSH. Yeah, that's it.
Yeah, and like people don't give enough credit to like people have done token protocols on Bitcoin before since time immemorial. Since the beginning, there will be more token protocols in the future. Like it's never going to end. And if this was your first token protocol on Bitcoin, then it might be new and scary. But this is just a thing that happens on Bitcoin sometimes. And it's like the right people at the right time in the right market had an impact that I think people didn't expect. But to what Andrew was saying about Taproot not really changing Bitcoin script in any meaningful way, like check sig add is different, but like that's kind of minor. The main things that Taproot really did, right, was we got Schnorr signatures, which are a lot nicer for safe, like multi-party signature schemes and for aggregating signatures. And then the Taproot part of it, like the actual Tapleaf bit, is if you have enumeration of different spending conditions, instead of having to do one giant script with a whole bunch of ors in it, you can now say, all right, I'm going to spend this leg of my script and have the rest be buried in a Merkle tree. And, it has to be an enumerable set of conditions. It can be a large number. It could be a million different conditions. And so people are doing interesting things with that as a construct. They're saying like, all right, I'm going to, like BitVM is this idea that like I'm going to take like an arbitrary computation and break it into a bunch of tap scripts and kind of like only reveal the one that I need to play out a specific part of the challenge. But it didn't actually add new scripting capabilities. It added sort of more script space and it added new signature capabilities, but it didn't change the nature of Bitcoin scripting. Right? It didn't like turn Bitcoin into Ethereum. It didn't give us loops. It didn't give us Turing complete contracts. Like it's still Bitcoin script. You just sort of have more space for your unused script now.
One thing that I think is important for people to realize is this, that like, if we could have had Schnorr back then, it would have been picked back then, right?
Yeah.
ACDSA has a lot of issues because it's a workaround Schnorr. So I think that the main issue there, at least to me, is that like, we have this mission critical piece of software that had essentially one algo, right? For the encryption that rules everything on it. And having a secondary one as a backup in case there's a problem with the first one or an implementation on the first one is kind of like really nice. You can pick a point in time and then sort of like just transfer everything over without having to test a new encryption type on Bitcoin. It's kind of like a big deal. And then like the Taproot stuff is like, okay, great. Now that we have Schnorr, we can do all this other stuff with threshold signatures. And, CDSA is not good for MPC. There's a bunch of other problems. Like CDSA is a bad thing. It was not a good thing to carry over to the future. So like, I think that's very important. And it's not like appreciated because when people think about that fork, people just think about Taproot. They don't think about actually Schnorr and why Schnorr is important to have aside from, the cool thing you can do. It's just having it is important.
Yeah, I was just going to say a sound technical upgrade. I think it's more of the cultural, social issue, like of why people have objections to it after the fact. No one's complaining about Schnorr signatures. And I even think just genuinely being able to, the reason like to have a pushback on the fact that I want to have a very large script if Bitcoin is programmable money and I want to have whatever I want and I'm paying my fees doesn't seem like an unreasonable proposition to me. It's just how the system should work as like an anarchic system. And for a little bit of context, Taproot was a lot of lines of code. It added a lot of new things, but to the point here, it didn't change the script interpreter. And really in modern inception of Bitcoin history, we've only had two opcode changes with check lock time verify and check sequence verify. So, and SegWit did not change the script interpreter either. So since like in the past 10 years, like I think we're coming up on anniversaries now where there actually hasn't been any change to the script interpreter itself. if we're just talking about Bitcoin as programming.
You could argue that it's a feature, not a bug. I mean, there's nothing wrong with not changing things. I think that's like where like a lot of the economic capacity in Bitcoin sits, right? That's okay. But, there is a market, right? And as the market is interested in other things, it's not a good or a bad thing. It's a market thing, right? It's like, what do the market want to do with this tool, right? Like, it's not my Bitcoin. It's not your Bitcoin chain. It's nobody's chain. It's everybody's. It's the market chain, right? So, like, how can we shepherd this in a way that is healthy and sort of like and doesn't ruin our bags so much that we're willing to fork it, right? And that's really where the nuance is on that. We can address that kind of shit later, maybe, because it's endless. But Andrew, go ahead.
Yeah. But just one minor point. I would argue that P2SH was also a change in script, but we can. That's, I think, more than 10 years old now.
And it was contentious.
It was.
It was very contentious. It was very, very contentious. I remember that.
That was a little bit before me, so I only know secondhand a lot of that. But yeah, they were like competing multi-val proposals, and but let's not digress. We want to.
There was a lot of screaming at each other in person. No, like this is before Twitter, Bitcoin became a big thing. Was like Reddit and Bitcoin Talk. But I remember being in some of the conferences at the time.
Mm-hmm.
And it was not pretty about this. The block size war had already been going on, and P2SH was sort of part of that too, because you're increasing, you're now making these big transactions in, and none of these things are new discussions. But anyways, P2SH came in.
So I want to talk about Taproot a little bit and say, like, if you're worried, maybe you don't like large scripts, and you're like, Bitcoin should be just the simplest thing, and like every transaction should be small and simple and so on. And, you don't want to enable things that will make scripts larger. Having Taproot should make you happy in that case. And in fact, having Taproot should not only make you happy, it should make you less worried about these large scripts. Because the premise behind Taproot, right, is that you have this large Merkle tree of, well, it can be large, it can be small, whatever. You have a tree of all of your different spending conditions. And you typically, if you're doing something complicated, you have, some fixed set of participants up front, and maybe all the participants are you, right? Maybe you just have like your hot key and then a cold key somewhere or whatever. And if all of the participants, everyone who has an interest in the coins moving, agrees, then they can just do a Schnorr multi-signature and just spend it without even revealing it. But maybe they don't agree, or maybe you lost a key or something. Well, then you can reveal an alternate branch that like shows a time lock and some alternate set of keys. And maybe that doesn't work either, or maybe there's some dispute. Then you can go to another thing that just kind of like zeroes in on specifically the point of contention and says, basically it goes to the blockchain and says, well, all right, now all of the nodes are going to adjudicate whether or not this condition is upheld. And so you can have a script that does, like millions or billions of different things and have all these different conditions. And if you only need to go to the blockchain to verify those millions or billions of conditions if there's a disagreement on them. And with Taproot, you're able to, by creating, fine enough trees, you're able to zero in on specifically the points of disagreement and reveal just that part of your script. And so what hits the chain is basically exactly the set of spending conditions which people disagree with enough to be willing to pay for the extra fees. Right. So we're really able to narrow down this. And what that means is that if we extend script so that you can express way more different things, that's not going to mean that all of a sudden people are all putting, like hundreds of kilobytes or, like megabit size scripts and stuff, right? You have things like BitVM where you're writing like literally gigabytes of script code if you were to actually like lay it all out and like write it all out. And even in the worst case, you do some like Merkle tree thing to zero in on your specific thing, and then there's a few hundred kilobytes, which is still awful, although it takes 6 months to get it on chain in the worst case. But in the happy case,
it's less awful.
In the case where people disagree on something simple or small, then you just reveal a single signature as though all of these gigabytes of stuff weren't there. So I think that's underappreciated, and unfortunately, like the inscription stuff kind of sends the opposite message of the truth, right? Where people look at Taproot as being a thing that enabled inscriptions, and they're like, well, inscriptions are massive and they're using all this space, and I want the space for other stuff. There are better uses than inscriptions. Well, that's just a minor consequence of the way we rejiggered the script limits, right? And you could do it before. It was actually less efficient to do it before. for both the network and also for people doing inscriptions, because you had to split stuff up. The really innovative change is that now if you're not trying to publish stuff, if you're just trying to get the blockchain to enforce conditions, but you don't care whether they're published to the world, then that's way smaller. And that scales super linearly. That scales, I mean, you can fit an exponential amount of different spending conditions into a constant size or linear. I guess if it's an exponential amount of information, it's a linear amount of stuff you reveal, right? Or if it's an arbitrary amount of information, it's a logarithmic
amount of stuff that you have to reveal.
Yeah.
There we go. That's how I should say it.
So guys, like, why do we want this, right? Like, I mean, we were just being sort of like, abstractly explaining it, and we mentioned a few things here and there. Like, why is OpCat so interesting, and why do we want some form of covenants? Like, why is so important?
So I think everybody probably has, I don't know, slightly different answers, but maybe there's some overlap. I think covenants generally are interesting in kind of two directions, right? So one direction is sort of with like more slowly moving money, and the other direction is like with faster moving money. So with like your store of value, slower moving money, I really want something like a vault or something else that lets me put velocity limits or velocity controls or more fine grain authorization controls on money that I either don't want to move, or I want to move at a specific rate, or I only want to move under like very specific conditions. So a vault is a great example of this. And going back to what Andrew was saying about like in the happy path, you just do a multi-signature. Imagine if you have some coins in like, I'm going to make up a number, like a 5 of 5, like multi-signature setup. And so to move those coins, you have to go and dig like 5 cold cards out of your neighbor's yards or something and like sign it. You can imagine if you don't want to do that because one of your neighbor's house burned down and the land flooded and whatever, you can imagine that there's like an alternate spend path where you say, all right, I can actually move this money with like one signature, but when I do that spend, it starts a waiting period. And during a month after I start that, I can go and cancel it and like claw that money back. But if I don't, then after a month, the money actually moves. And you can apply this to like inheritance scenarios. You can use this for custody things, like having this like velocity controlled vault is a really useful thing specifically for the store value use case. So that's like on one side. And then on the other side,
hey God, we'll get there.
Okay.
So just for the people who are listening who may not fully sort of like be with it, traditionally with like money transferring computer systems, right? We have these things called hardware security modules, right? That often have spend policies, right? So for example, don't send more than $1 per hour from this vault. That's it. That's the vault's rule, right? The challenge is we can do that. We do that in Bitcoin already. Exchanges do that. Everybody does that. The problem is who enforces the rule, right? If you have a computer enforcing the rule, you are still at risk because anybody can hack into that computer and change the rule, right? The high security or the people who are interested in security, like me or you guys, like the reason why we want this to be on chain rule is because you can't hack the chain. If you can hack the chain, I mean, then Bitcoin project is over. So the idea that those conditions are on chain really secure the pile much better, right? Like we could retire maybe hardware wallet companies, right? Like maybe I don't have to have a business anymore. I can finally go into retirement, but these are very large things.
Yeah, for sure. And like, NVK is going to complete his pivot to being an AI company, which will be great.
Just block clocks. That's it.
Yeah, just block clocks and unleash.chat. And then,
yeah.
So that, like one reason is that, HSMs come with a lot of operational cost. There's like the actual hardware, there's all the software development, there's the maintenance, there's the people, there's the compliance, there's like all this stuff. But also like you might have coins that you want to make sure can outlive the lifetime of a service provider, right? So like, if you're using this for like an inheritance use case, you don't want to have to worry about like, is my HSM vendor going to be around in 20 years?
No, and not, like all HSMs, they come with a what's the word again? It skipped my mind now. But anyways, essentially it has a lifespan that like they'll tell you like, listen, this hardware is like, this is, we promise to maintain this up to this life cycle.
Yep.
Right. Like that's it. All security chips do that too. It's like, listen, we expect the life cycle on this chip to be 10 years. People ask, why do we have to upgrade the hardware on cold card every 2 years? Well, because we deal with real security things, and the manufacturer says, hey, listen, we're going to be updating this in, say, like, I don't know, 5-10 years anyway. So why don't we try to get ahead of the curve and with the right thing? So like anything that is outside of the Bitcoin chain, which we expect to be there forever, has a life cycle and is short.
Mm-hmm.
So like, how can we do this that is like outside of a human life, right? Because when we talk about Bitcoin, especially the hardcore ossify Bitcoiners, right? Like they're trying to think about like, how do their kids in 3,000 years from now, in their pyramid, you know what I mean? Like are gonna like be able to like rule their spans then, right? in a proper low time preference way.
Yeah.
So like, we want these things on chain, both so that we don't get kicked in the head with a not kicked, a wrench, a $5 wrench to the head, right? Because you can beat me all you want, but you can't change the chain, right? We can achieve these things with some introspection for covenants.
Yeah, with certain shapes of covenants, like we can achieve those kinds of capabilities.
Exactly.
And then there's another kind of family of capabilities.
We're gonna get there.
Okay.
I promise you, we're gonna get to high velocity money. I promise you.
But that's the thing, right? And like people, like you can do vault-ish things now with just like a big bag of pre-signed transactions and ephemeral keys, but those systems end up coming with a lot of operational complexity. Secure key deletion is like a famously hard problem, and also what a lot of protocols and applications that rely on pre-signed transactions end up running into is that a lot of times you don't necessarily know the ultimate destination of the funds when you create the UTXO. And for pre-signed transactions to work, like you have to commit to those things up front and then usually like shred the keys in some way that people trust. And so, whether it's like vaulting schemes or the high velocity use cases that we're going to be talking about, or inheritance schemes, or other things where you want to have like future delegated spendability or future delegated custody under some set of conditions. The way that gets implemented now is with like very expensive software, usually assisted by hardware, and it only makes sense for like enterprises that are comfortable with like those conditions being enforced for some duration that's tied to like a business process. And being able to actually do that in your Bitcoin script would just be like a huge unlock for custody and all these things that we're talking about.
And it still sucks, right? And even when you have your $1 million solution, right? Like it still sucks. I mean,
yeah,
Fireblocks got owned because of how ECDSA works, and they were trying to do their multi-party computation shit, and it just, the implementation is too complicated and it didn't work, and money gone.
That's why covenants generally, and then like the question that you actually asked was why cat. The thing that I'm interested in with cat is that it's very simple, right? Like I like simple things that you can like think about and reason about it. It's 8 lines of code. You push 2 elements onto the stack. So it's easy to review for just like straight up implementation bugs, but it's also this very general purpose tool. So I think one of the places where we've gotten stuck on other covenant proposals in the past is that they've been more focused on like a specific shape of transaction or a specific shape of covenant or introspection. And a natural thing to ask is like, is this the right shape? Like, are we optimizing for the right use case? Or are we optimizing for the right kinds of transactions? And the thing that's interesting about CAT is that you can build kind of other covenants out of it. And so if it turns out that everybody uses something that looks like CTV or TX hash, except it lets these other fields be variable or binds these other fields to specific values or something, then we can talk about more targeted opcodes that's backed by actual economic usage data instead of trying to just like bike shed about it on a whiteboard. So that thing of like, it's this really generic building block that's easy to reason about and easy from like an implementation perspective. And then also, there's other things that you get out of it that are really useful. Like we can do some big number arithmetic in script. We can validate Merkle paths There's a thing that we can do where you can take a Schnorr signature and kind of split it apart and force users to use a specific nonce, and you can use that to build what's called a non-equivocation bond, which is like useful in like multi-party scenarios. So it's just this like very useful primitive that comes in this teeny tiny package that everybody can look at the code and say, all right, I'm pretty sure that there aren't bugs in the actual implementation.
All right, you opened the can of worms. So like instead of talking about use cases, I'm gonna have to bring up. So we do have other proposals, and there's a million of them, really. Like, and then there is the different permutations of parts of each too. There's the L enhanced, there is the CTV, there is I'm just gonna bring up the ones that are more talked about by the most Bitcoiners in public. Let's put it this way. There's TX hash, and sorry, Andrew, but Elements the diff is just too big, so I'm not gonna bring that one up. There you go. We have two simplicity shields here.
For those that are, since this is audio only, Rijndael and NVK are shirtless, and Andrew and I are wearing the Simplicity t-shirts.
I'm about to go get my Simplicity t-shirt from inside.
There you go. Actually, the truth is that Rob has a tramp stamp, a Simplicity logo. That's what he's showing us. It's very disconcerting.
It's so weird. Yeah, he's got this tattoo on his lower back. It's these like 7 combinators that are very low level, but you can formally reason about them, so you can use it.
Oh boy.
Yeah, it's wild.
Yeah, that's for the premium stream on Noster. You can go over and watch that.
So Andrew, like maybe you want to sort of like give us a little bit of the options that we have, and sort of like a little bit of their. I don't want to get into the weeds of the comparison of them because people kind of debate them to death, but like just to set the space so people understand why we're sort of going on this line.
Yeah, for sure. So yeah, when you asked about use cases for OpCat, right, you immediately, we were kind of focusing on covenants, and Rijndael pointed out, well, Cat does a lot more than just covenants, so it has this nice feature. There are a number of other proposals that are much more directly focused on covenants. And so there's things like OpVault, right, which are focused, just directly on enabling vaults. Because I think for a lot of people, you ask, what do they want covenants for? They'll say vaults, and then they actually kind of stop caring beyond that. For me personally, I would kind of consider myself, if that was the only covenant we had, I'd be happy. But then there are other interesting applications for covenants that would help. Let me give 2 other quick use cases. So one is sort of a payment pool. This is Jeremy Rubin's term, where an exchange can do, like 1,000 withdrawals at once. They put it into one output, and then using covenant opcodes, every user can withdraw their coins from that output and then put the rest back. And so everybody, in whatever order they want, with whatever fee rate they want, is able to kind of pull their coins out, and the exchange just pays for a simple fixed cost output that's very small for them, so they can pay a lot of fees. And then the people who don't need their withdrawal for a few weeks can like lowball it, and the people who need it in 5 minutes, well, they're screwed. But the people who need it in 10 to 60 minutes can.
No, but this is like fucking remarkable. Like it's
yeah.
I don't think people understand how mind blowing this is in terms of like custody.
Yeah, or so like when Jeremy wrote up that congestion control blog post, right? Like the use case that he really targeted was this like exchange withdrawal thing. But there's been a bunch of people who are looking at like what Ocean is trying to do with mining, and they're trying to have as many miner payouts as possible be in the Coinbase, and then do like Lightning for things that are below a threshold. Mm-hmm. And I know some people who are trying to look at this congestion control protocol and say, could we use this to do miner payouts instead? Right. And like not have a giant Coinbase that pays out 300 people, but instead you pay out to a script. And then when somebody is like wants to claim their payment, they're able to peel that off from the big basket of funds and leave everybody's money alone.
Yeah. So Jeremy has a proposal up CTV, which that's kind of the big use case that he's advertising, but it's actually a very general opcode. Although not as general as it could be, and it's focused directly on covenants. It's focused directly on transaction introspection. It lets you basically request a hash of all the transaction data, and you have some extra flags that decide which transaction data you're going to include and which you'll exclude. And then in your script, you can kind of control it. And then there's a related proposal, OpTX hash, which is basically CTV, except we split the V off. V stands for verify, right? So CTV is one opcode. You take all the transaction data, you make sure the conditions follow. OpTX hash, you take all the transaction data, you put it on the stack With a separate opcode, you can, verify whatever conditions you want. But if you don't want to do that, you can kind of do arbitrary computations, and then you get like much more general, open-ended set of covenants you might be able to do. Then another use case for covenants is for kind of layer 2 protocols, for like Lightning, for example, where in Lightning today, a payment channel, you're kind of like doing these constant updates of your payment channel, and every state update has kind of a previous state that's represented as a transaction. And everybody needs to keep all of these previous states around in case their counterparty maliciously or accidentally publishes an old state. And so you have this like crazy growth in the amount of storage that you need, and you need to be watching the chain for like all these different conditions and react in different ways based on them. And there's a whole infrastructure of watchtowers and all this stuff to try to wrap this up. With certain kind of covenant constructions, you can instead encode the rules for the payment channel directly into script. So when you update, then all of the old data, like any old state that somebody tries to publish, your script can recognize all of the different old states as being an old state, and then you have some sort of response that you encode. And so there's opcodes, or not opcodes, kind of one of the OG proposals that would enable this is sighash any prevout, or it used to be sighash no input. That's not even a covenant opcode. It just lets you sign a transaction without committing to the exact output that you're spending. And then you have to constrain it in some slightly different ways. And I think you can get some forms of covenant with this. We'll probably circle back. It turns out no matter what you do, you get covenants basically. But the sighash no input is not supposed to be a covenant output. It's just supposed to enable this kind of allowing you to spend multiple different old states. I think LN Enhance is kind of similar in its target. There's a few others that I'm probably not listing. I will mention Elements. Elements brings in just like a family of like 24 different opcodes, and each one of them like grabs an individual piece of transaction data and puts it on the stack. And then there's OpCat. And what makes Cat special, and Rijndael kind of alluded to this, Cat is very simple and it does a lot of stuff. So with all of these other proposals, you kind of have to choose one as a network. Like once we got OpCTV, we would never get TX hash because it's only a little bit better than CTV, and it's just not going to be worth all the consensus changes. And so if we get CTV and then it turns out that it's suboptimal for a certain set of use cases, probably we have to live with that suboptimality, because given the difficulty of getting consensus on changes and getting everybody to agree that we're making the right trade-offs and changing things, well, the benefit from going to no covenants to covenants is pretty big, and I think we can hit that threshold. The benefit of going from CTV to TX hash, that's much smaller, and then that's, it's that much harder to hit the threshold. So there's a lot of kind of like competition or animosity related to this, right? Like if you're a champion of some proposal, like you kind of need that to win and the other proposals to lose. With Cat, that's not the case. Cat enables all of these different use cases, but it does such a shitty job of it that it's not going to prevent anybody from putting a dedicated opcode in. And if we did put a dedicated opcode in, it wouldn't like obsolete Cat. And so now we all have to think about this like crust that we're carrying forever, because Cat's still good for doing Merkle trees, and using Merkle trees, you can do like arbitrary computations and all sorts of cool stuff. And you can do these anti-equivocation bonds and all these kind of constructions. Like those are still there. And Cat's actually the right tool for the job for doing Merkle trees and stuff. Like there's not going to be something that's significantly better than Cat.
So this is not like a silly compromise, or sort of like we're just sort of like, playing politics and exchanging things, and you know what I mean? Like, I guess like, I hated on OpCat for a long time, mostly because of, old days. And then I sort of remember it being a bad thing. And then sort of that's how it's stuck in my head. And then sort of like, just sort of like the humility of like going to read again, why is people bringing this shit back on, right? Like, are they attacking Bitcoin, right?
Yeah.
So I went to sort of like, I watched your presentation and like, I sort of like, oh, it was not that bad. It's just, it was broken. I think it's important to sort of like reflect a little bit on this sort of like the chances of us getting stuff in Bitcoin is going to diminish as time increases, right? Because there's going to be more people coming in and more different ideas and more things that people want that differ from other people, right? And that's the correct path. Like the correct path is less changes, right? So anyway, so like it was nice to hear that you have this opcode that's like, It seems to be a compromise that was there before and sort of like works for my vaults, and then for the velocity people who want to make that they need sort of like kind of like a shared UTXO, right, in order to have that velocity in the second layer.
Well, and something that Andrew just said that I think is really important to drill in on, right, is that there's a lot of really useful stuff that, even if we were to, in the future, get more specific, more targeted, more efficient opcodes, there's still really, really useful stuff that you're going to want CAT for. And in a lot of, protocols and designs that people are coming up with that use these more targeted, more specific opcodes, a lot of them either rely on CAT also being there or are made better by CAT because it tends to just be like a really useful, almost like glue code, right? Like it's a useful thing.
That's what scares people, right? It's like there is like this literal line. There is all this cool other stuff that could be possible, right? Like that's where the dick butt mind goes. Like the people who are at fear of dick butt and the people who want dick butt. Like it's like that's where they clash in the future of design, right? So like maybe we can de-risk a little bit this conversation by just explaining a little bit like where the design space goes in terms of like it's not just sort of like throw the shit on the wall and you can do anything.
Yeah, and I think that was a lot of the early CAT fear is that people thought that it was like op shell out to arbitrary program, right? Which like it's not like on its own, right? Like it lets you kind of destructure hashes, which is like a very useful thing, right? Like the cause of and solution to every Bitcoin problem is another Merkle tree, right? So being able to like work with Merkle trees in Bitcoin is incredibly useful. It also gets us around some like bad math that we have in Bitcoin. And then because Schnorr signatures are themselves a hash of a bunch of other hashes that are all concatenated together, CAT gets us transaction introspection because we can basically destructure a Merkle, destructure a Schnorr signature. So, the things that it gets us are like, we can do Merkle tree verification. We can do some amount of transaction introspection. We can do like big nums. We can, sometimes it is just useful to squish things together on the stack, like string manipulation. Those are the kinds of things that it gets us.
A quick grug brain thing that is important, like to sort of like bring up on this is that like, because Bitcoin is so restrictive, right? Like you don't actually run the script like in the Bitcoin chain. Like it's not like, we're doing that when we deconstructed transactions on the node, right? Like it's so what we do in Bitcoin to get around the fact that it's so restrictive is that we stuff things in Merkle trees and then we check the hash matches. That's all that we're doing in Bitcoin. It's not like Ethereum. We're actually doing some retarded shit somewhere.
Bitcoin scripts aren't for computing; they're for verifying.
This is the important part that people need to like get it.
Yeah, like the way to think of a Bitcoin script is a Bitcoin script is like a policy. Like, is this transaction allowed or not? Right. And so, your script is a way that you can programmatically express that policy. And sometimes in a policy, you need to like do logical or mathematical operations, right? Like, okay, I want to say this spend is allowed if 3 out of the 4 keys have signed. I need to be able to add shit together, right? Like there's like basic arithmetic and like logical operations that you have to be able to do. So if you think about like this Merkle verification thing that like we keep bringing up as an example, you could say, I'm going to pre-commit to a bag of, secret words. And if somebody provides one of them, then the spend is allowed. There's a lot of ways that you can implement that. But if you want to do it with like a Merkle tree, then what your script is doing is your script is validating that the secret item was included in this bag that you committed to with like your Merkle hash. With the transaction introspection capability, like if you're building a vault or if you're building a crazy L2 thing, what you're doing is you say, I'm going to send some coins to an address. And from that address, they can only be spent if the shape of that spending transaction matches a set of conditions that I bake into my script. So in like the velocity control case, like with a vault, you say, all right, the only way to spend these coins is they have to go to like this holding period. Spending them to that holding period is like a specific shape of a transaction. I'm encumbering an output, or I'm enforcing the shape of an output. You don't have to do, a lot of computation, but you need to be able to check that output matches what it's supposed to.
The hash of that needs to match a hash.
Yeah.
Like that's it. Like, it's not that the script is on the chain. It's just the hash of the script is on the chain.
Or parts of it you assert and then you hash them together.
But you're doing comparison operations at the end of the day. You're not running the full thing.
So like sorry, Rob, you wanted to put a point in. So why don't you do that before I do some?
Maybe it's best if we just go on because I don't want to change subjects. Let's just keep it rolling.
We can explore lots of stuff here.
Yeah.
So I think it's important for people to realize what we have now, right? Like, and what we have now is like really bad, like complicated Goldberg machines, multi-sigs, right? To try to do things around it, right? Like Lightning is a bit of a shit show because essentially we're doing all this completely insane multi-sigs, for you to sort of like find the equivalent use case. And then there's one of my least favorite projects, is BitVM. Like power, like, I mean, God bless your heart for trying to do BitVM, right? But like, like it's like every time people try to do something serious with BitVM, it breaks because like, it's just too complex, right? Like you create all this complexity around of just this very not meant to be used primitive, right? To accomplish the same, like, so it just doesn't work. Right. And you're going to keep on bumping into this. And then you have like degrading miniscript with Rob here. Also, God bless their heart, trying to do that. And, like same with Liana, it's like it doesn't work because you need to do UTXO rotation. Right. So like, in your case, it could work because, you're going to have a near zero velocity users of that vault. Right. So if they ever use it, really is because of they're done right with it, or they're rolling into a new thing, or they got robbed, and then you resolve that problem with the degraded multisig. But the point is, we clearly have market demand for all this specific needs, right? Like, we don't even have to get too crazy on the possibilities, but like, we need to resolve more conditional spending, right? Like just for everyday shit. I still have not seen any sort of solution around it that it's not crazy convoluted. It becomes essentially like non-viable, right? So like, maybe you guys want to like have some opinions on this, but like, I think that's where we are now. We're a stalemate. We're like, you have complicated things that barely work, that nobody's willing to really invest the time in because it's just too complex, going to break anyways. So you invest time trying to come up with proposals that maybe you can, enchant the economic nodes to maybe activate in not too far of a future.
This brings up what I was going to say, is that CAT is able to execute this. And Rijndael, I have your perfect vault here. And I guess this is kind of what our buddy Reardon Code, author of Ellen Hans, calls CAT script, where I think there's 22 CAT operations on the stack to be able to do this covenant, right? And I think like it shows the versatility of CAT and that you're able to do these things. For me, I think like it goes also to the mailing. Andrew, you had this post on the mailing list a while back about how whenever you're thinking about new design spaces of something you want to do possibly in Bitcoin, like OpCat gets you there 90% of the time. So it's this general tool that enables these kind of use cases to maybe not restrict Bitcoin in a way where you're actually able to use your money on your terms and kind of have a more evolved form of programmable money.
Yeah, it is. It's very versatile. And I'm trying to think how to respond to your comment about complexity, because it is true that like a lot of the complexity from Lightning comes from not having covenants and not having the ability to rebind transactions and trying to set up this incentive structure where money is correctly routed and misbehavior is correctly punished in a model where all you can say is once enough conditions are met, the coins go wherever they go, right? And this is also true of BitVM, which is fascinating. Like, you could certainly convince me that BitVM is possible in the abstract, but it took a very special kind of person to actually try to build it, right? And that the fact that they like somewhat a little bit succeeded in some cases, right, is quite impressive. But most people just like wouldn't even try it. The complexity is just through the roof. And so, as Rob kind of hinted, there's still complexity with cat, right? You're still trying to do something like a vault, and you're doing it by using 22 cat opcodes in order to construct, pull together a bunch of synthetic transaction data, which you then hash up and then like jam into a transaction or into a signature in a clever way. But the complexity is contained inside of a single script. And so you aren't trying to reason about what happens if, like one of the participants in this protocol decides to do something that's unexpected. How do you punish misbehavior kind of stuff? Misbehavior just isn't possible, right? So if you can convince yourself that your script is correct, you just deploy it, and then the script will make sure that things work. And so then many of these protocols that require multiple transactions and these incredible trees of transactions then kind of can, in many cases, collapse to one or two transactions. And there's an analogy to much of regular cryptography, which is in crypto, you have two broad categories. In like modern asymmetric crypto, you have two broad categories of protocols. You have interactive protocols and you have non-interactive ones. So signatures and zero knowledge proofs and things like this are non-interactive protocols, right? Somebody produces this thing, they put it on the chain or they publish it or whatever, and then it sits there and it has like inherent in this blob of bytes are all these cryptographic properties. Interactive protocols are where multiple participants each have some secret cryptographic material and they need to interact in a certain order within a certain time frame in order to produce some sort of output. So MPC is kind of like the most general form of this, but like multi-signatures and threshold signatures and all this stuff are also examples of it. And what we found in the Bitcoin research space was that interactive crypto was unbelievably harder than non-interactive crypto. Like with non-interactive crypto, we were like doing non-interactive zero knowledge proofs of arbitrary programs. And like we were able to get our heads around that and publish papers and a reasonably short. Well, I mean, once we got over the starts for C, like, is this possible at all hump, there was a tremendous amount of work going into this and a tremendous amount of progress all of a sudden. And people could implement these. You could have production ready NISICs and stuff. And like these do literally any computation. You can prove that computation was valid without revealing anything at all about the inputs that you use to produce. It's just incredible. And then you try to do like a signature where two people interact to produce a digital signature, a Schnorr signature, which has been around since 1990, right? A 30-year-old, like dead simple thing. It's so simple it shouldn't have been allowed to be patented, but water under the bridge. And you try to get two people to interactively join that. And with music, this is what we did with music. We took 3 iterations. Our first iteration was completely broken. Like you literally could, one participant could maliciously generate keys in a way that their key would algebraically cancel out the other party's key, and then they could like take control over the signature. The second iteration had this whole extra round of interaction that we had to add, this pre-commit phase that we couldn't even we at first didn't believe it was even necessary. We're like, this is just an artifact of the proof techniques we use. And then somebody actually broke the scheme without having the pre-commit phase. So, okay, we need it. And then we had music 2, and this was the one that I wasn't even involved, which did this clever dual nonce combination thing and was able to get rid of the extra round. So now it's only 2 rounds. But this is the simplest possible thing that we're doing. But as soon as you add interaction, it becomes so much more complicated. You got to think you don't only have a signer and a verifier, and the verifier really has no power. You have multiple signers. What if they try to cheat each other? What if they deviate from the protocol? What if somebody just disappears? What if somebody responds late? What if one participant gets forked and then they're participating in 2 parallel protocols, but they don't know that they're participating in 2 parallel protocols? What if you do some rewinding attacks? What if you blah, blah, blah? It just blows up. And so things like Lightning or especially BitVM are interactive crypto. And they're not using, low-level mathematical primitives of groups and addition. So it maybe doesn't scare people as much, but it should, because it's this crazy, huge interactive thing that's so hard to reason about and just awful. And so cat, as ugly and horrible looking as the cat solutions are, they're non-interactive. And that's really where the magic happens.
If I could ask a follow-up question, because you mentioned Starks, and I think that was a chatter a couple weeks back about how with OpCat you can do Stark, which is a form of a zero knowledge proof, and with that you can do rollups and other kinds of scaling systems. And I was talking to someone and asking how large are these proofs, and they said under the consensus limit.
I mean, that's all that matters.
They're very large. They're very large.
And so I guess just to very concisely lay it out, when we're talking about to try and look at the other side of this, if the question is, if we thought the silly dick butts were taking up the chain and all this speculation trading was crowding out transactions, if there's actual economic activity that are taking large amounts of block space, how that impacts the overall use and game theory of Bitcoin.
Think about just one thing. Like, I don't know if you guys remember this, but in the block size wars, there were a lot of exchanges not doing proper UTXO management, right? And some could say malicious, maybe not. Who knows? There's a lot of idiocy out there, especially Coinbase, and it's very easy to fully congest Bitcoin by just being an exchange doing P2SH. I mean, P2SH is very extremely costly on bytes, extremely costly, right? Like, and it does not take much. So, and then if you just like follow this line of like rationale with security, meaning like saying that like, hey, anybody who's doing real amounts of money should be using multi-sig P2SH, right? Then like, fuck, you're fucked. Everybody's fucked. It's not the dick butts, right? Like, it's just the fact that everybody's doing the thing the right way, right? And not necessarily doing, even with better UTXO management, it's still only 4 megabytes. Even if it was, 32 megabytes, it doesn't matter. There's 8 billion people in the world, right? So like, once this stuff just scales out to more people, and it doesn't matter what it is, we're going to congest the chain. Like, a good Bitcoin is a congested Bitcoin. Like, that's what it was designed for. So we're just congesting it earlier by having 4 megabytes.
Well, there are improvements we can make though, right? So
absolutely.
I mean, Taproot's a simple one, right? So if you're using P2SH multisig, where you're publishing, every key that might be involved and then publishing a signature for every key that actually is involved, that's not so great compared to Taproot, where you can combine all of the signers into a single public key and a single sig. Starks give you something similar. So the S in Stark stands for succinct, which is hilarious because these proofs, the proof itself is like 100 kilobytes, like over 100 kilobytes. And then imagine the script code that's pulling apart this 100 kilobyte thing and like using cat to like reassemble Merkle trees and so on. It's very large, but they scale very well. So kind of what Starkware is doing is this like transaction aggregation kind of roll-up model where they have, they've got some sort of like centralized aggregator node or whatever, but everybody's putting transactions, they're giving transaction to them. They compress all the transactions so that single 100 kilobyte whatever blob is then containing, but arguably an unlimited number of transactions. It could be millions or billions of transactions. So there could be a compressing effect there. There's also room for research into compacting Starks, right? So Starks are, and if you're willing to accept a trusted setup, actually, you can do non-Stark zero knowledge proofs. And I think that you could, even though you have to implement the verifier in script, you can probably get something smaller than a Stark. So there, and I'll just remind everyone that in Taproot also, if you have a fixed set of participants, they can all agree and you bypass the whole verification. Not always roll up kind of things, right?
Well, and on top of that, like a model that a lot of people are playing with, which comes with its own complications and risks and complexity, is like this optimistic verification model where you just say like, I'm going to try to spend,
right? And
there's a waiting period, and then if somebody challenges you, then you reveal the whole Stark on chain, right? So this is very analogous to like the Taproot thing of like, in the happy case, maybe you have either more interactivity or you have some delay or something. And then in the unhappy case, then we duke it out on chain with like the giant cat fry implementation that actually like checks the Stark. And if you're using, a Stark or a snark that wraps a Stark or something else to basically do like transaction cut through, which is really what we're talking about, you're doing all these transactions off chain, and then you're coming back and you're saying, here's the results, and here's an argument that these results are valid. That can be like an incredibly economically dense activity. If you're taking like all this data that would be on chain and you're replacing it with one Stark that's tens of kilobytes or even hundreds of kilobytes, like that might actually still be a good use of chain space.
An analogous to this asymmetry of value, right? Like you have all this this transaction economic activity happening, and it gets like a small little proof on chain, right? You have the audacity of the BRC20 people, right? Like, which really caused all the problem. It was not the dick butts, it was the BRC20 stuff. It really is fascinating, right? The dynamic you have that, because that was already possible with RGB and other things. Like, you have all this computation and all these actors doing all this stuff, and then through whatever protocol convoluted thing they decide to use, they put a single proof on chain, right? And that single proof can be quite tiny, really, because the burden of all the checking and the computation is outside of Bitcoin, right? That's what open timestamps does, right? Like, you can have a bunch of proof, like a bunch of things hashed, then have like a tiny single proof that like when you break that out, like, it's like a lot of stuff was there, right? The whole Wikipedia was there if you wanted to, and you just sort of like using this concept, right, of trying to limit like what you're putting on chain, and that's what we want to incentivize, right? Because that's what economically makes sense. It makes sense to them too, right? Like, it makes sense to all these actors to pay the least amount as possible on chain, because again, as Bitcoin scales, we're very tiny amount of people right now, but as Bitcoin scales, it's going to be like BIS. It's not going to be a dude in Africa buying a latte with sats. Those sats are going to be worth a lot, right? And for you to make a transaction on chain is going to cost a lot. So that is the path that Bitcoin goes, regardless of, if you want covenant, if you don't want covenants. We're just trying to figure out is like how to best accomplish that without over engineering, without breaking things to future proof it. So I think maybe we could, unless you guys want to argue more about the Stark stuff, I'll take another tangent here.
But before you go on another tangent, like another thing just to touch on, Rob was talking about, I appreciated the backhanded compliment on how many cats I used in my script. Thank you, Rob. But, like he was talking about that complexity. And I think that there's sort of like a conservation of grief thing here. Like where do we want the complexity to be? So the approach that we have right now with getting stuff off of chain is to rely on highly interactive protocols with economic incentives that keep people from spending the money the wrong way. Because like right now, you can only say like either you're allowed to spend this coin or you're not, and you're not allowed to really say like how you can spend it or how much you can spend it. It's really just like if you can spend the coins, you can spend them. So whether it's Lightning or vaulting protocols or whatever, we just sort of rely on like, we're going to trust you, but then we'll have some punishment mechanism later if you do it wrong. And we're going to have like very interactive PSBT passing protocols effectively to like mediate this. And that's a lot of complexity. And that's a lot of complexity that ends up being felt by every user of that protocol, which is one of the reasons why it's so difficult to do non-custodial end user Lightning wallets like on your phone, because like you have all this interactivity that your phone has to be a party to. If we instead said we can shift that complexity to the time that the developer is writing the cat script, right? Then we can like invest in static analysis tooling. We can build higher level abstractions. Like we can engineer safety into that complexity and force that complexity to be felt sort of when you're building the application, and then have users not have to interact with that complexity. And I think that complexity is actually one of the things that prevents a lot of these systems from gaining adoption. And maybe we can move that a little bit.
That's like the perfect segue into like what I was going to maybe bring up, which is risk, that we kind of touched a little bit, but so I was talking to Rob a while back when we were talking about like script templates, right? Mini script, dangerous as fuck. You can have a mini script accident instead of a boating accident. We had that meme going a while back, but that's like, this is just like an engineering problem, like in terms of like, hey, like, did you engineer it right? Right? Like it's not like it's not a showstop problem, right? It's just that like, maybe we have a community driven like safe script templates for you to pick from, and and we have them signed and they're beautiful, and we can even store them in the Hyrule wallets. Like, if you're not using one of these, we refuse to sign it. Like there's all kinds of cool stuff you can do, like to add safety, right? We do this for aviation, we fly. I know it's crazy. So, what are like, if we had to like sort of steel man a little bit, the the people that don't want to add cat, right? Like, what are some of the risks that we have to sort of like really keep in mind so that we can engineer like, safety going forward if you get cat?
So there's kind of a broader ossificationist. It's a bit of a mean term, but that is what it is, right? There's an opposition to extending Bitcoin at all, right? And like I've sort of mentioned that like cat gives you covenants, but like so would almost any script opcode. And it's kind of an accident of history that Satoshi in 2010 disabled not only cat, but also limited the arithmetic to be a certain size and restricted the comparison opcodes to not be long enough, and gave us SHA-1, which was pretty sketchy, but not MD5, which was also sketchy, and so on. And all these different decisions all at once prevented us from having covenants. Like, you very effectively kind of shut the door to extracting the transaction data from the checksig opcode, which is central to Bitcoin's functioning. And there's maybe an argument that like this was design providence, right? Like somehow through these like unrelated stupid bugs, like guided Satoshi's hand into disabling all of the things that would give us covenants. And as a result, Bitcoin is a much simpler system where all you can do is move money from point A to point B, and the money is free, right? There's no way really to say like the coins need to be trapped in some loop, or the coins like have to get burned, or whatever people are afraid of covenants doing. You can do it, but you have to do it using multi-sigs, right? So if you wanted to control the path that coins would take forever and ever, you could say, well, I'm not going to accept coins unless I am a multi-signer. I am party to that transaction. And I'm not going to sign any transactions that don't continue to preserve my counterpartiness. And all of everyone sending money to you and receiving money from you has to agree to go along with your ridiculous control. And that's a social problem, not a technical problem, right? And there's a fear maybe that any sort of covenant functionality could turn that social problem into a technical problem, I think. And I don't think that's correct, but I think that's the fear.
Yeah. So like, just to add on that, like, we already have that. I mean, like, there is all kinds of idiotic ways of like creating Bitcoin wallets and storing Bitcoin wallets and signing Bitcoin wallets, and people do that all the time. It's more like a personal responsibility kind of problem than it is a technical problem, right? Like, people were doing, what was the name of that wallet? There was a brain wallet website. People were, creating brain wallets. People do multi-sig with the same general purpose computer for all their keys, right? I mean, like, the tools that we have in Bitcoin, they don't enforce how you use them, right? Like, you can be an idiot about it, right? Like, and that's all. Like, we build safety by offering better solutions and market those solutions better so that people use those solutions that are better, right? Market is great for that. So like, I don't buy that argument of like, yeah, but people could lose coins. Yeah, people lose coins all the time for doing stupid shit. I mean, you can do that with P2SH. I mean, P2SH is, again, absolute disaster. I hate P2SH. But,
Maybe one that's, I think maybe a couple months ago started rearing its point about cat kind of taking at, rather than the script level and you as the user level, but like at a network aggregate level, was this concept that if you bring in more advanced layer, like more advanced layer twos, like a roll up that are a lot more complex. It's not just a direct payment channel, that this could introduce some form of minor MEV. And the very condensed version of that is that there would be ways that mining pools and miners themselves could construct blocks differently to give them extra value. And the problem with this is that Bitcoin by design is supposed to be egalitarian, where you can use the Bitcoin Core block template generation, and you should be able to get mostly like the best economic block, right? And the idea is that this complexity in other layers would be able to allow miners to have an asymmetric advantage if they had more engineers and software kind of monitoring the network state to try and get additional fees for themselves.
Yeah, I want Andrew's opinion on MEV, but I just want to put one thing there, which is like, Bitcoin is not egalitarian at all. Bitcoin is actually very plutocratic, sort of like indexed. We just have a fair set of rules that are immutable that everybody gets to use it, but like economic capacity does, give you an advantage. And the economics in Bitcoin are designed so that, like people choose to not break Bitcoin by, letting the economic actors like behave economically better.
Yeah. So I think maybe the word Rob wants is not egalitarian, but scale free. The idea is that if you're Bitcoin mining, right, you spend twice as much money mining, you'll get twice as much hash rate kind of thing. You don't spend twice as much money and get 10 times as much hash rate, and then you get to take over the money, the network, because you had just a little bit more money kind of thing. And that's still not quite true, but it's supposed to be true, right? There's not supposed to be economies of scale. And the idea behind MEV, right, is that it introduces these economies of scale, where if you're a mining company or a mining pool that hires all of the quants and all of the black hats and so on and figure out how to break every single thing, then you will be able to extract more money from mining than the other mining pools who don't have those experts and those proprietary algorithms and so on. And we see this happening in Ethereum. There's like a whole massive wild industry of MEV in Ethereum because Ethereum encourages Ethereum has always been designed for arbitrary general purpose computing, right? And I think there's a fear that people see cat, they hear, people like me saying, well, with cat, you can do anything, right? You have a Merkle tree, just pre-compute every computation. You look it up in the Merkle tree, general purpose computation, right? And they hear, whoa, like this is going to be people writing crazy programs that can be solved in multiple ways. And the miners are going to figure out how to manipulate the solutions and extract money and so on. Or they hear people talk about tokenization and they talk about, coins on top of Bitcoin, and they worry we're going to have AMMs, which are not terribly complicated in terms of computational complexity, but you have AMMs that are processing transactions. People are depositing and withdrawing, and then there's an opportunity for front running and so on. And the thing is, in Ethereum, like kind of at every layer of the Ethereum design, there are this is encouraged. So there are two big things in Ethereum that are not true in Bitcoin. One is there's what's called a key value store, right? A global key value store. In Ethereum, you write a script, it stores data on the blockchain, and then any other contract can access that by calling your contract and requesting it, and so on. In Bitcoin, you can't directly store data on the chain and then recover it in script. You can't say like, this is, here's my database of everybody's balances on my special token. What you have to do is you have to store it off chain, and like your off chain storage could, I guess, in theory, be somewhere else on the chain. But like conceptually, you have to store this data off chain. In your covenant script or whatever your script is doing, you need a commitment to the state of all of your storage. And then your script needs to load stuff out of that commitment, update the commitment, and then show that you have a commitment of before and commitment of after. And then your next stage and whatever your transactions are, you need to, take the after guy is now before, and you do these steps this way. The second thing is that Ethereum has an account model rather than a UTXO model. And this means that every address in Ethereum actually does have a balance associated with it, and every transaction that spends money from that just deducts from that balance. Whereas Bitcoin has a UTXO model where all the coins are stored in these individual indivisible units, and when you spend coins, you destroy a integer number of UTXOs and you create new ones, and you cannot reorder. You cannot reorder them. And the effect of both of these things is that in Ethereum, you can reorder transactions, and you can dramatically change the shape of transactions and the way that they behave while still being valid, right? So if I have an Ethereum address with 10 ETH on it, and then I make, 11 transactions that all spend 1 ETH, well, 10 of those are going to get into the chain and be valid, and one of them will not, okay? And there's no way, I can't really control which of the 10 will be in it. It's going to be whichever 10 are most advantageous to the miner, right? Whereas in Bitcoin, if I have a 10 BTC UTXO and I want to spend that, 10 times in a row, I need to spend that whole 10 BTC, send it back to me or send it to a staging output and chain them. And I'm forced to create a tree of transactions that has an inherent ordering. So the miner can't reorder stuff. And when I'm trying to manipulate state, I'm forced to do it by having a state commitment and a new state commitment. And then my script needs to enforce that you go from one state to the other. And again, you have this inherent ordering. And BitVM exploits this to do like, you can do like tic-tac-toe games and stuff on Bitcoin where you get the same efficiency as Ethereum, where you're not forced to create these exponential sized trees of every possible transaction. But there's still an ordering. One player goes and the next player goes and so on. And when you're developing stuff on Bitcoin, It's possible if you stretch enough, right, to emulate an account system and emulate and reorderable transactions and so on. But you've got to stretch to do it, right? The native Bitcoin system really discourages you from doing this and encourages you to just use the UTXOs and use state commitments, and those give you ordering, and that increases your ability to reason about stuff and decreases opportunities for MEV. So I get the intuition that MEV on Ethereum is like this complete Wild West, like nightmare scenario of massive centralization that would destroy the network. But cat's not enough to get us there. I'm not convinced that any script extensions are enough to get us into that situation.
Not even BIP 300?
Kind of related to that, right? There's another big difference that it's related to the account model thing, which is that like when you have a transaction, even if we had like full first party transaction introspection, right? Like Liquid has some opcodes where you can say like, what's the amount on this input, right? Like you can fake that with cat, but you're not faking it. You're getting the actual amount, but you have to use 22 cats to do it. Even with that, the context that you get in a transaction is bounded by that transaction. In Ethereum, your transaction exists in the context of this whole global state that like everything can read everything else. This is what Andrew was mentioning with like the state model. And part of the reason why that's really important is it means that you have data dependencies on your transaction and maybe the transactions that came ahead of it. You can't take arbitrary data dependencies on like somebody else's transactions that are completely unrelated. You can kind of do it with like SPV proofs, but it gets big and complicated and like dangerous. And one of the places where I ran into this is I sat down to try to build an on-chain AMM for runes, which is like a new token protocol that's been pissing people off.
To put mildly.
Yeah. And I wanted to see what would it actually look like? Like, I don't think this thing would compete economically with like custodial order books, but like, could you do it with OpCat? And something that I found is that colored coin protocols, which runes is colored coins, inscriptions are colored coins, BRC20s are kind of like a weird account-based colored coin model. Colored coin systems rely on the history of that coin for you to tell whether or not that coin is valid. So if you think about like an on-chain decentralized exchange, like a Uniswap thing, where you say, I've got 10 NVK coins and it trades at some ratio against Bitcoin, and I want to put in BTC and get out NVK coins. The script to implement that has to be able to validate the balance of the NVK coins on the inputs. And in order to do that, it has to know the history of all of those tokens and be able to validate in Bitcoin script that the transfer rules for the lineage of all these tokens was valid. And when you have like fungible tokens coming together, you end up with like a script that you can't write, because like I can't stuff, variable arbitrary amounts of Bitcoin transaction data as witness into another transaction and then validate that this like correctly implements the runes protocol. This is another big difference between Bitcoin and something like Liquid. Liquid has first class support for assets. So you have an opcode that says, like, tell me that the third input is Tether. We don't have that in Bitcoin. Unless we add asset support in Bitcoin, like no amount of introspection opcodes is going to let us do succinct on-chain dexes using colored coins. Like it's just, like the system just isn't shaped for it.
One good like a proof that like this is an impossible problem is that Ethereum has like claims to have like a couple of archival nodes. It's what they call a full node, because you have to unwind every single script, every single nested script, and every token on every single, like you have to like unwind this infinite design space in order for you to account for everything. So it's essentially impossible. That's why we're always happy as Bitcoiners with get UTXO info, and Grug Brain, you get a count of all the UTXOs that are on the system, right? And does it match and we're good.
I think it's also another thing that's just interesting to point out is that like protocols and systems that leak MEV to L1 miners will get outcompeted by protocols that don't, because like if there's MEV to capture, that means that users of the protocol are losing value, right? Like if a miner can front run you, then like you got a worse price.
They all moved to proof of stake anyways. Like they gave up because it's pointless. Mining is pointless in all those systems.
Well, and like what we're seeing in those ecosystems is like the L2s that they're building in Ethereum have centralized sequencers that don't leak MEV to the L1 because like they want those fees because they have to like hire engineers and build wallets and build block explorers, and like that shit's expensive. And like the economic model for them to do all that investment and to build out the crazy L2 is to be able to like capture all the trading fees. Like they don't want to be leaking all of that to L1 validators.
I don't know if you know this, but they moved on from that too. Like a lot of the talks now is how to do their state machine insanity, but validate with Bitcoin proofs. So they're all sort of starting. There's a lot of that going on.
Yeah.
The demand for block space is coming, regardless of how I feel about it.
Absolutely. I guess to call out too, just for developments ecosystem where you could do this, Signet now has cat activated, right? And a really funny thing to talk about, like things you can do with Bitcoin script if you have cat, is AJ Towns put forward a proof of work faucet for Signet, right? That you're able to basically do mock work to be able to get Signet coins. And it's just, I think it's really interesting as a concept to enable all this stuff. And I actually have been using Signet, and I go and look at the blocks on chain, and I'm seeing the fee rates are already spiking up. You know, people are messing around with it, and all those scripts have cat. So there's a lot of people that are starting to play with this. Wallets out there are adding like connections to it to try and start messing around with this, the cat scripts in general. I think it's interesting to see it all be developing over the past year. And do we want to even touch the thorny issue of activation, or do we want to just keep this strictly technical today?
We can do the activation later when we're tired. So like, let's go back to steel manning, like maybe the other side's position for not like for risks and things with cat, right? Like, so the MEV, you know, like at least on this sort of conversation, it seems like, you know, people are in agreement that's not real concern. Losing the coins, well, that's an operator problem, and that's already possible. What else here? Like, I mean, you know, I fail to see anything that is like do or die. I don't see like an economic change to Bitcoin's dynamics, right? Like that could be a concern, right? And those are trickier for us to know, right? Like where things could sort of, you know, snap.
One argument that I hear thrown around, and it's not a serious argument, I'm going to say it for the sake of completeness, but it's like, oh, well, this is going to enable more shitcoining, and that's going to like dilute Bitcoin.
That's coming.
Yeah, it's coming. And like anything that makes Bitcoin better for Bitcoin, like also makes it more useful for shitcoining. So
exactly,
accept that into your heart.
Anything that makes Bitcoin better money isn't explicitly going to enable shitcoin use cases. There's no way around it.
The way I like to say it is, if open timestamp is possible, okay, shitcoining on Bitcoin is possible. Because like, no, seriously, like if you can stick a proof in Bitcoin anywhere, right? Like a hash that's big enough that's good for you to use it as a proof, right? Like it's possible. Like so like that cat is out of the bag. This cat is different. Andrew.
Also, I don't think serious argument, but a common one is you mentioned BIP300, right? And some people are really like freaked out about BIP300. So for context, BIP300 is Drivechains, right? It's Paul Sports' concept of doing
sport.
It is sports, yes. It is of doing a sidechain, like an SPV validated sidechain, where you kind of take all of the weird minor incentives around that and just like fold it into the system. So you have on Bitcoin a script opcode that knows how to validate SPV proofs of the activity on your sidechain. And you use that so you can move coins into the sidechain, and then you use this like new kind of Drivechain opcode to move coins back. And the Drivechain opcode will like look at the history and check that you show that you do actually hold the coins after a certain amount of activity on the Drivechain. And the concern there, right, is that almost by definition, you're always looking at a finite horizon of the Drivechain history. And the Drivechain history is maybe, it might be merged mine with Bitcoin, it might not. But there's all of a sudden an incentive where individual Bitcoin transactions have basically an unlimited economic potential for rewriting them. So what I mean by that is that in a Drivechain-like scenario, rather than miners being incentivized to rewrite blocks only in kind of pathological situations where like you have a single transaction with some massive fees or something. Drivechains could cause external incentives for miners not to move the chain forward, right? And the idea with BIP300 is that there's like various economic penalties and blah, blah, blah. And like somehow these incentives are pointed in the right direction, but like ultimately they're not. And if you have CAT, then you can emulate op Drivechain, right? You can emulate BIP300. Well, if you can in Signet verify proof of work in order to run a faucet, you could certainly in Signet verify proof of work on actual Bitcoin blocks. And you could write Signet scripts today, which are validating Bitcoin blocks and doing weird things with those block headers. And for one thing, I feel like this is like, if this is your complaint against extending Bitcoin with CAT, this is your complaint against extending Bitcoin, period. So this is really an ossificationist argument, or an argument that Satoshi was accidentally right to lock down all the things that he did, which, I mean, I'm sympathetic to. I don't want to dismiss that out of hand, but it's a really big claim that you're making that we should basically never extend script.
Mostly because it's already possible, right? Like, look at BRC20. You have a single transaction that rules this other atomic system. There is like a whole universe that's just based on that, right? So that transaction could be, let's say that token on BRC20 is worth, $1 trillion, right? Like it's already an incentive for you to keep on trying to steal that or try to rule that or never sort of putting that on a chain. Like the incentive is already there.
Right. And that's almost like accidental, but you could also do it on purpose. So Vitalik has an ancient blog post called the P plus epsilon attack, where essentially on Ethereum, you're validating Bitcoin blocks. And on Ethereum, you publish an Ethereum program that pays out a bounty for somebody to attack the Bitcoin network. And you can do that by just validating Bitcoin block headers in Ethereum and saying, I want to see that like at block 900,000, I want like a million different, like for every block 900,000 you give me, I'm going to give you the equivalent of 50 Bitcoins. And so now when you're a miner, once we get to 900,000, you can either mine 900,001, or you can just remine block 900,000. And then this Ethereum script's going to give you some BRC20s, which you can then trade on a centralized exchange. Like, I don't know how you're going to get the cash out, but
There's always a sucker.
Right, exactly. So Drivechains and BIP300 kind of are of a broad category of like, people could externally build systems that mess up the Bitcoin incentives. And we already live in a world where that's possible, right? And I guess the reason it hasn't happened is because people are basically good.
No, but you could make the case that like the economic incentive is still bigger for you to not break Bitcoin, right? Like it's like if it was in everybody's interest to try to do something like that, I mean, first of all, there can only be so many markets for that, right? So because there's only so much economic capacity out there. So you could have it so that, maybe there can be one of those scams, right? That say break Bitcoin that way, right? But the reality is there is more economic incentive in Bitcoin for you to do Bitcoin stuff.
Right, yeah.
Go feed chickens or something with Lightning. There is more economic capacity there, so it protects Bitcoin that way. I mean, it's working as designed.
Or like maybe another shape of this, right, is like, if you create other ways for miners to sell the work that they're doing for Bitcoin blocks, then that adds the scale that Andrew talked about earlier. And there's kind of like already ways to do this, right? So if we're this is now a podcast where we're going to talk about like fun ways that you can break miner incentives right now. My favorite one that I came up with lately is since we now have like runes and BRC20s, but I think it would be better with runes. You could imagine broadcasting a Bitcoin transaction that pays no fee, like no L1 Bitcoin fee, but includes as an input like a rune or some other colored coin, and then has like an anyone can spend output. And the idea is that you broadcast this, and if a miner is running like the right sidecar software that like knows that this thing has value, they're going to include it above other transactions that are actually paying fees. And it like messes up everybody's fee estimation. It makes it so that like miners who are running this like other index can like make more revenue. Like it totally messes up the whole like economics of Bitcoin for fees. And like this is a thing that you can do today with no permission, no soft forks. Like, you don't have to change Bitcoin to do this.
You have to alter mempool policy, though, right? If you have a zero fee transaction, by default, it won't be relayed on the peer-to-peer layer.
Okay, that's fair. So you do 1 sat per view byte.
I do that all the time.
Yeah. Or you peer to miners, right? Which is like a thing that I can tell you can do.
Libre relay.
Yeah, Libre relay.
I think that the point is that Bitcoin can be broken in 50 different ways when it comes to miner incentives, right? But it isn't, right? Why isn't it? Like, like to today, right? It's been 15 fucking years. We're still here. Okay, state actors have infinite printing money capacity, right? The inflation for them won't catch up before they break Bitcoin. So, you know, and why isn't, right? It's because I really think that the economic incentive when it comes to the majority of the network doing the good thing, between quotes, is economically more sound, right? So they do that. There is always more money to be made by keeping the system whole, right? Even if you, like, you know, there's variance, but there's going to be always variance and some turbulence. But, like, you know, there was a small period of interest in dick butts, right? Like, and that shit dies. It's all fads because it's not real economic activity, right? Like, there was a small brief period where people were scamming people with BRC20 tokens. There's always going to be this sort of like variance periods where, you know, the incentives like sort of struggle, but they always prevail, right? They prevail because in the long term, having a single UTXO with, like, you know, like $1 billion worth of value, right? Like, it is true economic density that needs to move. And you can't fight that. You really can't fight that, like, that density in there.
I buy that. I want to buy it. I mean, empirically, you're right that we are still here after 15 years, right? There's got to be a reason.
I mean, really, like, you know, I have nothing else, like, because, like, you know, the power that state actors have, like, people don't appreciate the insanity that these people go through to break shit, right? I mean, look at the XZ. I mean, they've been working on that shit for years, right? Like look, like, it's insane the amount of, like, effort and like infinite resources these people have, right? And we're still here with the most dangerous thing to a state actor, which is financial freedom, right? Like, so like, and they're fucking with it. Like, don't get me wrong. Like, one of us is a spook on this call, right? Like, 1 in 4 people. so like, it's very hard for a human to put faith in a human-made thing, right? Because we've only been here for so long, right? But you put faith on that granite that, you know, like, you build your house on. So like, it's just because he was there, but it's very easy to drill granite. You know, it's just that confidence. It's hard for us to, like, it doesn't matter how much math we have behind. It's very hard to believe on that proof. Sorry. End of rant.
So, smushing 2 elements together on top of the stack is probably not going to break that. Just throw that out there.
Unlikely. You know, I think we should be prepared for unwanted consequences, right? Like, you know, there will be some other stupid shit that people are going to do on top. But I don't think there is a breaking thing that could happen. I think there's a lot of stupid shit that will happen.
Maybe a thing that we can do is, in the discourse, separate actual technical risk from unwanted usage, because this is what it is. Like, the people who are mad about Taproot enabled dick butts, which is not true. I have that on very good authority that that's not true. Like, what they're really mad about is that, like, people are using Bitcoin for things that they don't want, and, like, they don't like that, you know, those people are using Bitcoin in, like, that way. And, you know, as Bitcoin grows, if Bitcoin continues to grow and continues to be adopted and, like, find more use cases that it's, like, useful for, then, like, Bitcoin is going to be used for things that you don't like. And so saying we're not going to improve Bitcoin because it might enable a use case that I find unsavory or unpalatable or doesn't comport to my views of how Bitcoin is best used isn't, like, the right way to stack rank, like, what things we do or don't want in Bitcoin. If we want to talk about, concrete risks or economic risks or game theoretic risks. Like, I think that that's all fair game, but hey, this will be like wildly successful at getting the wrong people to use Bitcoin is like probably not a serious criticism.
I had a conversation with Olivera recently, recorded one, where I think people conflate like the Bitcoin fairness, if you want to put it this way, in terms of like everybody has equitable rights to a certain sets of rules, right? Like you don't get a little bit more of a rule than anybody else. That's where Bitcoin stops, right? In terms of fairness, that's it, right? Like you don't, like, it's not your chain. You don't have control of what people do with it. To be fair to the other side, because you're not represented, like the people who are more extreme on the other side, let's put it this way. I'm in the middle. Like I don't have a side in this game, I guess, because I have sentiments that want to ossify and sentiments that want more features. I mean, I'm a normal person when it comes to that. To be fair, to steelman them a little bit, is that like, like you could consider like a bug, that certain behavior is possible. You could say that it has economic harm, like there's like lots of sort of like more soft arguments there. And then there's remediations, right? I mean, you could change certain things that will make some things go away. I disagree. I think people are still going to figure out a way of being retarded, because you can't prevent people from being retarded. But the key thing is, it's not how much you dislike something, it's how much economic incentive or how much economic interest there is into do that thing. And if there is economic interest in do that thing, it's going to happen. It doesn't matter how. People are going to figure out. I mean, fuck's sake, like ordinals is just complete insane. Not the inscription side, but the ordinal side is just like Casey's choice of word and domain that rules his sort of like, esoteric way of how to read the tea leaves, right? Like it has nothing to do with Bitcoin. Like it's just people will ascribe order to our chain in a way that may benefit them economically or emotionally or both. But like, I find the conversation around that like a fucking waste of time. I'm more interested is like, okay, what can cause economic harm or economics that can cause harm to Bitcoin, or, like technically what could happen here. And that's the point of this conversation today. Thanks for coming, Rob.
Cool. Thanks, Rob.
Take care.
Bye, Rob.
Okay, so, and I have now 2 Galaxy Brains left here. Before we get maybe into a little bit of activation stuff, because I think it's important to always bring up that, because if a person listens to this is the only thing they heard about it, maybe there is a touch about that. But before we go into activation, any other aspects of Cat we should mention, or, like, because CTV felt like he was kind of getting there, the thing that people were sort of started to rally behind. Sure, it's a different set of trade-offs and sort of like, its own limitations. And now it's Cat. Seems like Cat has a little bit more weight behind. So like, what other things we should talk about Cat that maybe didn't get addressed?
I think one thing that's interesting is I've been just trying to explore what you can do with Cat and trying to help people understand what you can do, what you can't do, what that actually looks like. Something I think is interesting is that there's a lot of other proposals that include Cat as a component and then like add other things to it. So, like on one far end of the spectrum is, Rusty has this proposal. I don't know if he's calling it this or if other people started calling it this, but like the Great Script Restoration, which is like, we're going to turn on all of the deactivated opcodes, and, Cat is a subset of that, right? So like Cat's included in that. And some of the kind of uglier Cat scripts end up being obviated by other opcodes that get activated. So like an example of that is multiplication. Like if you haven't tried to write Bitcoin script, it might be surprising that you can't currently multiply 2 numbers together in a computer programming language. Like that's wild. You can fake it by like duplicating and adding over and over again, but just like straight multiplication is like not a thing that you can do. So if you want to do large number like multiplication, you can technically do that with Cat and addition and like duplication.
Why would you need that?
So let's go back to our vault use case. Let's say I want to say you're only allowed to spend 10% of the value of this UTXO. Like I need to do the math, right? There's like lots of places where when you're dealing with money, where you want to be able to like do basic 3rd grade math on money. So I think that that's like interesting that there's these other proposals to expand the scripting design space more. And I think it's a thing that I was surprised by is that most or all of them end up including either cat or something that's functionally equivalent to cat, like you're destructuring hashes but in like a slightly different way. So I think it's interesting that people coming from different directions have kind of like seen this always as like a lowest common denominator like building block. And then I think it's also just interesting that, you know, L2 stuff, L1 vault stuff, like different parts of the ecosystem tend to need something shaped kind of like cat. I think that's like really interesting. You see other software proposals that are like really targeted at like one specific L2 or like really targeted at a use case. And I think that it's, you know, maybe the reason why you're seeing the excitement around cat right now is because it scratches a lot of itches.
Andrew.
Yeah, it scratches a lot of issues and it's simple. And it doesn't compete. I really think the big thing is that it doesn't preempt other things. With a lot of the other covenant proposals, right? CTV did definitely have more momentum than any of them, but even with CTV, there was a fear that it was incomplete somehow, right? Like we have to get it perfect because it's going to preempt anything that's sufficiently similar to it. And cat is so small, there's very little room to bike shed, other than I guess on like the limit on how large you're allowed to concatenate stuff. And so far, nobody's like shown up on the mailing list like griefing that number. Knock on wood.
Oh, it's coming.
There's not a lot of room to bike shed this thing, but also if we have cat, that's not going to kill other covenant proposals, right? Because particularly doing covenants takes 22 cats, and it kind of sucks. And also doing multiplication with cat is much better than doing multiplication without cat, but it's still not good, right? Like we want an optimal, like I'm a big fan of Rusty's proposal, and I hope that he finishes whatever benchmarks he needs to write it down and publish it in text. I'm a big fan of that.
I think the Great Script Restoration narrative is like great to rally devs. It's a terrible, terrible, terrible marketing sort of package for users and economic actors and business and stuff, because it has that ominous bill vibe to it. It's like, look, I'm gonna like do all these things, and it sounds like you're gonna like, you know, sneak in something in there, and so like it's a very like I'm very torn on this one in terms of like how to, because Bitcoin is politics, Bitcoin is people, right? Like, and at the end of the day, like if you can't sell, right, like whatever next thing that you're gonna do to the economic actors in you know, it doesn't happen, right? Or creates more strife.
Yeah.
That's sort of like one opinion I have about this. I think it's like the intent is awesome. Maybe the packaging could use a little work.
No, I think you're right. It tries to bill itself as like just restoring the things that were dropped, but not quite, because it needs to add a couple things for Taproot, right? It adds a tap verify and some byte reversal thing. And also it introduces this costing model that is pretty easy for consensus code to reason about, but quite hard for wallet developers and programmers to reason about, right? And that just didn't exist before, right? Before, the cost model was, you know, like if you want to shut down the network, then you just type the right code, right? And that was, you know, simple in its own way. But this new costing model, which is necessary so it doesn't blow things up, it's a tough sell. And Rusty isn't really selling it. You know, he's not a salesman.
No, I mean, like it's hard. Like, you know, I talk to this like ad nauseum now, but like I don't want to like speak for people or sort of like reduce people to this very specific categories. But it's kind of like, you know, autistic people sort of like they don't want to talk to people. They want to just work on problems, solve problems. And like, here's my paper or here's my implementation. Like, you know, please like activate. Right. And then on the other side, you have like people that have absolutely no idea how the shit works because, you know, it's very complicated. And like, there's very few people who understand Bitcoin deeply anyways. Right. Like, and you know, most devs in Bitcoin understand that they don't understand Bitcoin. And so like the gap is so wide, so wide that like, I don't have a good answer of like how to bridge this. And I don't think the lovey-dovey sort of like, you know, let's kumbaya around shit, just it's going to solve that gap either. Right. So I think that's where the stalemate is always going to be in Bitcoin, is like how to like get people on board. And it's a good thing that people don't get on board that easy, right? I mean, like that's because if it was easy, then state actors would already have broken Bitcoin by just getting people to go in a certain direction, right? Op-evolve. Look, I was at the CIA meeting. You guys want to try op-evolve?
Yeah, I mean, like another thing, right? Like I really like great script restoration, both technically and I think also it's nice that it avoids the bike shedding in a different way. It says like I'm not going to pick which of these proposals is good. We're just going to turn on the opcodes that we used to have and add sort of taproot analogs to them, right? Like we didn't need tweak verify pre taproot, so it didn't exist, but it's sort of in the same flavor of like all the rest of what's in script. So it like makes sense that it would be there. I think the thing that'll be like an interesting challenge, one of them that I haven't seen enough people talk about, but it makes me chuckle, is the new novel costing model feels a little gas-like. And people are already worried that like string concatenation is going to turn Bitcoin into Ethereum, which it doesn't. The variable ops model, if people say like, oh, does this add gas to Bitcoin? It doesn't. It doesn't add all of the gas problems that Ethereum has of like your transaction fails but still costs you money. Like none of that exists. But like memes rule consensus, right? So that's like a thing. The other thing that's like I think going to be just an interesting journey if anybody wants to champion the effort is people don't want to change Bitcoin just to make devs' lives easier. They want to change Bitcoin because it's going to like solve problems for them, or because they think Bitcoin is never going to get to what they want Bitcoin to be unless we make this change, right? Like I'm really interested in things that improve like L1 custody, because in my view of the world, if we don't improve L1 custody, then the natural like rational market response is to have more custodians and to have fewer people self-custodying Bitcoin. And so like I think it's important that we have things like L1 velocity controls in order to like make it so that more businesses and people and large entities can like hold their own keys safely. So I think it's like what we'll have to do, we being like the Bitcoin developer community, if we want something like the Great Script Restoration, is we have to figure out the way to articulate like what are the problems that this solves that aren't just like, oh, the devs want it. Because like that's not reason enough for economic actors to upgrade their nodes.
Andrew, do you mind explaining a little bit with more meat, like the costing model?
Oh, of Rusty's thing? Yeah. Basically, what it does is it looks at so when you're running through a script, you always know the size of your inputs and the size of your outputs, and you're able to bound them, I should say. And or I guess while you're executing your scripts, you're able to the size of your inputs. And basically, what it does is it charges you one unit of cost, and I'll explain what that is in a sec, for reading a byte, and 1 unit of cost for writing a byte. So if you have like opcat, and it also uses kind of like a naive or simple model of how these work. So with cat, right, you read something off the stack, you read another thing off the stack, you write them smushed together. Okay, so the total length times 2 is how much cost you have. And in practice, yeah, like actually you would take the first thing and then in your memory, you would extend your original vector and so on. But we don't consider optimizations like that. And the cost is weighted, as I recall. It's kind of the scale is set so that everything kind of costs like SHA-256 on a single SHA-256 is sort of like the natural unit of computational cost. So if you are hashing, and I think it was the hashing 520 bytes, which currently is the most computation you can do with a single opcode in Bitcoin, except checksig, which is special and already has its own cost. And then, well, that's basically it. So for most of the opcodes, it's fairly straightforward. Like cat's fairly straightforward. You read the things, you write them 2x. Op-rot, like the rotation, the one that just moves stack things around. I think those are close to free. But then things that actually read the contents of the stack elements, those cost whatever the size of those are. So op-add and op-sub are also, you read, so add, you take 2 things off the stack, you read both of them, you write a new thing, which is the same size, maybe plus 1 bit, right? And so the cost for that is the sum of your 2 things plus the size of the maximum of the 2. Multiplication is more complicated. He brings back op-mul, and there you have like this quadratic formula, and one of his slides has the formula for it. I guess there'd be something similar for op-div and op-mod, but I don't know if they were in its slides. I was kind of scrolling through it before this, but I don't remember. But that's basically the costing model, right? It costs to read a byte, it costs to write a byte, and you model every opcode in the kind of like naive, obvious implementation. And this has, like, you can see how that's simple for the consensus code to implement, right? And it's simple. Anybody can read it and kind of verify that this is a natural way to do it. It is unfortunate that it considers naive implementations, right? So for one thing, like things like cat obviously are not actually going to cost 2n and whatever. That's a small constant factor. It also, like, it doesn't include rolling SHA-2 opcodes. So there's a natural way to hash large amounts of data, right? So your hash engine, as you're hashing data, you're actually only storing like 64 bytes of data plus a length counter at any given time. And you I think it's actually 32 bytes for SHA-2. And that means that if you're hashing like a multi-megabyte file, you can just read it, put it into your hash engine, it crunches it down to 32 bytes, or plus the incomplete read. So there's your 64. And you just keep doing that. And you never need more than 64 bytes of memory in order to do this. But in Rusty's cost model, doing that would cost the same amount as reading all of those bytes. Well, why don't you just have a model where you create an object on the stack that's big, and then you hash it all at once? And that has the same cost in Rusty's cost model. So as a consequence, the only way to hash massive amounts of data in Rusty's scheme is to build a giant stack element and hash it, which in this abstract idealized thing is the same thing. But in real life, building a giant stack element requires allocating a bunch of memory and probably copying a bunch of memory and so on. Whereas, and potentially allocating multiple times if you're building it up by catting things. Whereas a rolling hash opcode incurs none of those costs. Right, you're just like feeding the data into a hash engine. You do it all within registers. You do it all on your function stack, like in the C++ logic, and it's much faster and more efficient. But the costing model can't reflect that without being more nuanced. And so there's this trade-off between how many optimizations and nuances do you try to fit into the cost model versus how simple can your costing be. And then if you get it wrong, right? If you get it really wrong, in theory, you could have an Ethereum, like you need to fork the system because you can blow up people's computers. That's pretty unlikely because your script can't access, like do random disk access and do all sorts of things that have pretty bad cost. But that's one failure mode. If you just like fail to cost things correctly and your on-chain costs are too low. Then the opposite failure mode is that your on-chain costs are too high. And then you have opcodes that are basically unusable because they're so expensive, but because they preempt everything similar to them, you can't get consensus to go fix it because it's not a big enough improvement. So that's the toughest thing about this, right? And I think if I was going to ignore my own feelings and predict what happens with this, I feel like it's just going to founder on that. Like something like we're just never going to get consensus on the cost model.
Yeah, it's sort of like I think what you're saying is it's almost the jet argument of like, which optimizations are we considering to be like consensus critical optimizations, right? Like, okay,
yeah,
everybody's CPU has, an instruction to do this thing. So we should, say that that's free. And, then NVK is going to say like, no, cold card, that's not free. That's going to be expensive. I think there's another part of it too, right? Which is like, to be clear, I'm a big fan of script restoration, but another part of it is that in order to make this like usable, I think you're going to have like tooling to do all this stuff, right? You're going to want something kind of like Miniscript or something else where you say,
yeah,
all right, I'm going to author my script and I'm going to, eval it and see what the cost is. And I want to profile my script and say like, here's the hotspots. That's all really good tooling to build. Like we should go do that. But I think that kind of thing is also what we're going to need to make this actually usable.
It's hard too.
Yeah.
It's not everybody out there that's going to be able to to write that, right? Like it's the implementation bottleneck there. Wallets are fairly simple now. I mean, between quotes.
It's also like it's a cool model. It's the other thing that I think is like really interesting about it is, I think if you're interested in script restoration, it would be cool to go and start trying to build things using all these other opcodes and show like what they look like, and then maybe use that as like a reference implementation where if the community decides we're not moving in the direction of script restoration, but this is still a really useful opcode, you might be able to distill down like, oh yeah, well, if we had this, and this, then we can enable this use case. Like it's a useful bag of stuff to be able to build cool scripts out of.
Yeah. I really wish the conversation excluded the extra color around it. It's pretty brutal right now because the people who want it are tired of waiting, so they just say fuck it, right? And they just go like full retard like around it. And then the people that don't want it are also tired, so like they're like just like full retarded like on the other, like it's pretty brutal because like I feel like when the discussion is like that, like it's very hard to have like a good analysis on things from different sides, right? Like you're not getting like people to truly pay attention and like make sure that shit's good, because that's all I care about. Is it good? So I guess like this is unless you guys have anything else, like please interrupt me. I think like maybe the like, you know, how do we activate this? I mean, I'm very simple brain on this. I am a flag day person, a flag day maxi. It's like, you know, you gather as many people as you can. You know, when I mean people, I don't mean people shouting on Twitter. I mean talk about like economic actors, you know, and miners, and you go like, okay, you know, I feel personally that I have the team that's big enough for me to sort of champion this and get out there, right? For a flag day. I know a lot of core people don't like flag day because, you know, it's more dramatic, it's more painful, and you know, I understand why you do not want to that being in that position, but like I feel like it's the most fair and best way of doing these things. You know, speedy trial, I think I've come to realize that like I can't do anything about preventing speedy trials, so it's gonna happen anyways. It's just like it's a good thing, right? Like when there is things you can't do anything against, it truly is like a special thing. Anyways, that's sort of like where I want to start the conversation, and you guys sort of, Andrew.
I mean, I'm broadly a fan of speedy trial, right? It's similar to a flag day, but you have like a pretty high activation threshold. And if you fail to get that, then you just kind of like back off and then reassess kind of like outside of the technical consensus mechanism. With Taproot, there was kind of an interesting thing, right? Where we did this speedy trial and then like it succeeded on the first shot, right? And with Taproot, there was all this like weird like artificial drama where people were afraid that like mysterious unnamed actors really hated Taproot, but nobody could quite say who these people were. But like it had happened with SegWit, so you know, like surely it was going to happen like any minute now. And finally, we just did the speedy trial and ran with it. So that's probably, I don't know, like I don't want to do it, right? Like maybe it's on me or Ethan or so, like maybe somebody just needs to do it, right? So a natural follow-up question, like beyond what way do you want to activate it or what do you think will happen, is why hasn't anybody proposed activation parameters yet, right? And nobody has. And I think maybe everybody is just waiting for somebody else to do it. And like, I don't want to do it. I'm waiting.
Yeah, there is not a lot of incentives for somebody to be the messenger, right? In such an adversarial environment. Like it's the messenger gets killed on Bitcoin pretty much every single time, right? We always joke that we need a big sacrifice before the bull run starts, right? Like, and that's only on the economic side. That's not even on the technical side. I don't know. Like, I mean, I love the idea of a non-actor building a UASF style client and saying like, here, go. Like, this is the flag day date. You know, maybe speedy trial dates and like go.
Well, I like that. If you don't have a reason to believe that the miners are kind of adversarial, though, like it gives you a wide margin of safety to have a mechanism where the miners have to signal some sort of buy-in, right? Because then that avoids the risk that you have a fork of the chain that like runs away and people are accidentally on it or something like that. So like I get like it's cool in like cypherpunk to say like let's have a UASF and like everybody, you know, like we're all sovereign citizens and we can choose our own Bitcoin. That's awesome, but in practice, right, like it's a lot of extra safety for hopefully not a lot of extra social or political cost to have a mechanism where we bring the miners in.
Yeah, I guess the part that I don't like about speedy trial is that like it gives a soft advantage to the miners, right? Like,
yeah,
you know, essentially like it's information asymmetry here now, right? Like they're essentially signaling, hey, you know, I don't want this, and they will always not want something that may be bad for them, like or maybe not ideal for them. So like I don't know, maybe it's just like being, you know, over cautious or whatever. It's just I never liked that part of it, but because I can't prevent it. Like maybe it's the way that we try again, right, and see where it goes.
Well, and it's kind of, it's like if there was some activation attempt, like, and the way that the current proposal that Ethan and Armin wrote up in the only BIP number that I remember now is BIP 420. I know that there's another BIP number that other people think applies to it, but like whatever that BIP is, BIP 420. The way that is written,
6969.
Yeah, and hey, github.com/BIP420 goes to the cat BIP. That's all I know. So the way that that's written, it's using this like op success mechanism that Taproot introduced. So if a economic minority of the network starts enforcing opcat, and as long as nobody broadcasts a transaction that gets into a block that misuses opcat,
right,
like they're not going to fork off the network. It's only if somebody includes a transaction that would fail otherwise, but they see it as an op success. Somebody would do that if they thought that it would be funny, or if it would like make a point, like like that's probably going to happen. But there's kind of like three actions that you can take if there's an activation attempt because opcat uses op success. You can either like try to activate it, you can try to like enforce the rules, you can do nothing, or you can run an alternative fork that invalidates cat. Right. So this is like Jeremy wrote a thing for CTV that would like reject blocks that include CTV. I wrote a thing that would that rejects blocks that include inscriptions. And I encourage people to run it if you really hate inscriptions. I think what would end up happening, right, is like if there's a activation attempt that's not super contentious, that like a lot of people don't actually care about cat, the likely thing to happen is that like people just wouldn't upgrade, and it's just there's not enough of the economic network running cat to make it safe to encumber real money with cat. And I think that's like an okay outcome. Like that doesn't split the chain. It doesn't cause people to like lose money who aren't doing reckless things anyway. I think, the only time that it gets really spicy is if people are so mad about cat or so mad about the activation that they'll run a separate fork that invalidates cat. And I don't think people are actually that angry about concatenating elements on the stack. It seems like the thing that get people's cackles up the most is the activation mechanism. So I kind of feel like a lot of this conversation is very similar to like Taproot, where like Schnorr signatures and tap trees were not contentious. Like I don't think anybody was like, oh no, fuck Schnorr signatures.
Well,
like
also nobody fucking understood anything.
Yeah.
Like it's
the thing that people were mad about was speedy trial. And so yes. I think that there's like a similar conversation here where the thing that'll get people to run something that invalidates blocks if it sees 7E in the script is going to be like an activation drama, not a cat drama.
Correct me if I'm wrong, but as I understand, it would be a similar dynamic but inverted than the Bcash, right? So essentially inverted Bcash, or inverted SegWit. So essentially, like you'd have to be invalidating so that you would essentially fork off this time around. So it's the inverse of the block wars.
I think so. I have to think about that.
Yeah, it's been over 2 hours. It's hard to think.
Yeah, that's what we get. People, they can't be prepared for this show. Like people come, the bullet points only last so long.
No.
It's gonna come out that Andrew Poelstra is not a real cryptographer. He's actually an English teacher.
It's true. Always been bullet points.
Always been bullet points.
That's right.
Peter Willa mails them to me every morning.
He doesn't even check the signature.
That's right. No, listen, guys. I think we've beat this one to death. Any other sort of like things that you think that somebody who heard this 2.5 hours should sort of keep in mind or like should have it?
I hope that somebody proposes an activation. So one kind of final comment is despite all this talk, nobody's proposed any activation proposal. And like I kind of wonder if I should just like make some stupid thing, say like, how about we activate it tomorrow, just to like start in motion the idea that we could activate it, right? Because I think maybe like nobody wants to make the first move, right? As you said, right? I mean, the messenger always gets shot, right?
Are you ready to retire from Bitcoin? Is that what you're telling us?
Yeah, exactly. Yeah, that'll be my final move. That'll be my like exit scam. It's just like I activate cat. It turns out it was a bad idea the whole time. And
Mic drop.
Bye.
so yeah, that's my closing statement. You know, like you listener, go activate cat.
If anything, it's going to teach us that nobody wants it. Like it's a win, I guess, for everybody. But like, please make sure that the actual activation date is like fucking 2 years from now. You know, like don't do the dumb shit of putting for next week. Literally, you know,
Yeah,
like
for sure. We should be cautious. There's no need to. There's no urgency to this, right? There's not. I don't think there's really any organized or like really strongly felt opposition to cat itself. I think a lot of the opposition is either like kind of opposition by association, because like cat is associated with like taproot wizards and maybe people are upset about inscriptions and, you know, blah, blah, blah. Or associations with just like increasing computational expressivity feels like Ethereum or something like that. And the people who are upset because of those associations, but not really digging into the technicals are not. I mean, those like we're never going to convince all of those such people, right? That's kind of a natural human reaction, but it's also not a very strongly felt human reaction, and we shouldn't take that to like as like something that's blocking that we have to somehow resolve all such opposition. And then when you clear through it, there's not a lot of technical opposition there, and there's no. It really doesn't directly affect mining incentives in any way. I think there's still a lot of fear based on the SegWit/ASIC boost thing that like somehow there's like some large component of the ecosystem that would be harmed or helped by cat that we don't see. And then that's going to mess stuff up. But really it's turning an op success into something that concatenates two elements. It's very simple. It's very narrow. We should just do it.
I think I resonate on there's no urgency to any change to Bitcoin right now. It's not like this is not an existential problem.
Yeah.
I think that if any proposal, whatever it is next, if it's given enough time, like long lead time, I think people will have a lot more respect for it. And I also think that like a lot of people are not going to put the effort into understanding it if there is no activation proposal, right? Or like, you know, it's just a waste of time, right? Like to just go, you know, analyze yet another thing that it's very unlikely to happen, right? I think that's how a lot of people feel about these things, and there's a tragedy of the commons there. So, yeah. Rijndael.
I think Andrew said like everything that should be said. Like we should just go activate it. I think the flip side of there's not like an existential, it's not like quantum computers are coming out tomorrow, so we got to like change the signature scheme today, right? It's not that scenario. But also, I think it's worth keeping in mind that, like the Bitcoin network is made up of all the software that everybody chooses to run. It's open source software. You can like run whatever software you want. And so, Bitcoin's ability to change or not change is a decision that we make, and like it's not like we're fighting against like gravity or like some natural thing that we have to escape. Like if the Bitcoin community decides that we want to do a thing, like we can go do it. Like we can just go do things. We can just go activate cat.
You don't need permission.
Yeah. So it's this thing where I think a lot of people think that there's like some process that we have to do. And those are all just like things that we made up and tell ourselves. And like we can just go do it. So we should just go do it.
Okay. All right, folks. I cannot thank you all enough for spending a little bit of time and
brief chat.
A brief chat. I feel like it's quite amazing that how much you managed to pack in 2 hours and a half. This topics are week-long topics, right? Like and like we did manage to civilly get into a lot of nice little corners here. So thank you very much for your contribution. I think these things are extremely invaluable to people. Maybe they hear in another better pod where, like the interviewer is a little smarter. But the people need to hear these things, and they need to be explored in like the minutia and the big picture. And it's not easy. Nobody understands Bitcoin. And who knows? Maybe GMAX approves the next fork on a Reddit note on our gardening for some reason, and then that's it. It gets activated on Bitcoin, right?
Yep.
I really hope not.
I am perfectly fine with a consensus of elders. You know, like I think there's nothing wrong with that. It works for FreeBSD. You know, it works for SQLite. Extremely successful projects. But anyways, like, listen, thank you so much for this. If there is anything you guys want to leave before we hang up here, just please let me know.
Flag Day next week.
Please don't put the flag day for next week. You can post the software tomorrow and make it for 2 years from now.
That's right.
Or it's like a 100% certainty of failure.
All right. Thanks, guys.
Andrew's leaving.
Yes.
No.
He's going to literally go type shit now on the mailing list. Okay.
Already did it. It's already sent.
Oh, shit. All right, guys. Thank you so much.
All right. Thank you.
Thanks for listening. For more resources, check the show notes. We put a lot of effort into them. And remember, we don't have a crystal ball, so let us know about your project. Visit bitcoin.review to find out how to get in touch.